Welcome, sir. Bakshi sir, welcome. Dr. Virender, sir, welcome you. Dr. Vanish, welcome you, sir.
Thank you.
Good morning, everybody.
Good morning, ma'am.
I welcome you all to this two-day international conference on new trends in chemical research that is being organized by our college. Welcome, Bakshi sir.
Thank you very much. Thank you.
Yeah, I will start formally, just shortly.
We have time, yes.
Yeah.
Good morning, ma'am.
Good morning. Principal sir, take my contact colleague. I welcome all the honorable guests and all the participants to this conference. We'll be starting shortly once the principals are joined. Thanks for joining us. Suresh sir, I am properly audible or not?
Yes, ma'am, you are audible. You are.
Thank you.
Hello, Professor Deepak. Good morning.
Yes, sir. Good morning, sir.
Sorry, urgently in meeting, so he will not be able to join. You may proceed for the same.
All right, all right. Thank you.
Okay.
Thanks for the information, Sumit sir.
Okay.
Okay. Welcome everyone to this first session of 2-day International Conference on New Trends in Chemical Research 2022 being organized by Shahid Udham Singh Government College, Matak Majri. I am very delighted that you are all with us today. And now, with the permission of the convener, Gulab sir, I would like to start the conference formally.
Yes, ma'am. Yes, ma'am.
So, as you all know, the conferences, these are the platform to exchange ideas on various paradigms of research. So, I'm grateful to the chemistry department of this college that they conceived the idea to organize this conference where various experts and various researchers from the field of chemistry may exchange their ideas. To start the conference formally, I would request the organizing secretary, Dr. Suresh Kumar, to deliver the welcome speech, please.
Thank you, ma'am. A very good morning to all of you. I, Dr. Suresh Kumar, Organizing Secretary, with immense pleasure welcomes you all in the 2-day International Conference on New Trends in Chemical Research. I feel honored to welcome our worthy chief guest, Professor Ashok Kumar Bakshi, founding Vice Chancellor of PDM University, Bahadurgarh, Haryana. Welcome you, sir. I also feel privileged to welcome our keynote speaker, Professor Neera Raghav, Chairperson, Department of Chemistry, Kurukshetra University, Kurukshetra. Welcome, ma'am. I welcome to Dr. Satish Kumar Bhardwaj, Principal of our college, for giving us permission to organize this event. I welcome Dr. Gulab Singh, convener of IC and TCR, who worked really hard in organizing this conference. I also welcome all the committee members and volunteers who worked hard to arrange this event. I would also like to welcome all the staff members of our college. Welcome you all. I wholeheartedly welcome all the eminent speakers and delegates across the globe. We are also proud that we are organizing this event under the aegis of Department of Higher Education, Haryana. Last but not the least, I welcome all the media persons who will cover this event in these 2 days. Welcome you all.
Thank you, Suresh sir. And now I would invite the convener of the conference, Dr. Gulab Singh, to kindly inform us about the scope of the conference, please. Dr. Gulab Singh.
Thank you, ma'am. Thank you, Deepa, ma'am. I, Dr. Gulab Singh, the convener of this 2-day international conference, welcome you all. This is the first in the history of chemistry department of Shahid Udham Singh Government College, Matak Majri, Karnal, to organize a completely digital conference on a huge scale to share the scientific research minds of this era. We are also proud that we are organizing the conference under the aegis of Department of Higher Education, Haryana. The title of this conference is New Trends in Chemical Research. Today, the whole world is fighting with COVID-19. So, the huge responsibility comes on the shoulder of all the scientists and researchers of the world that they should protect the whole world from this pandemic. In this process, the role of chemists is going to be very important. Through this conference, we will know about the different research and innovations taking place in different parts of the globe. We all will share our thoughts and ideas with each other so that the new thoughts and new ideas will come out. We will discuss the method by which the chemistry can be more interesting so that the maximum number of scholars and researchers will be produced. We all will discuss about the exploration of chemistry with the help of digital tools. This conference provides us a platform to discuss the recent innovations, trends, and concerns, as well as practical challenges encountered and solutions in the field of chemistry. I hope this two-day international conference, ICNTCR 2022, is going to be a milestone to know and understand chemistry. With all these hopes and best wishes, I thank you all for joining this event. Thank you. Now I request to Dr. Deepa Sharma to proceed further. Thank you, ma'am. Thank you.
Well, thank you, Gulab sir, and best wishes for the success of this conference. As you all know, this conference, International Conference on New Trends in Chemical Research, it is being organized under the noble patronage of the Department of Higher Education, Government of Haryana. I heartily congratulate the chemistry department of the college for conceiving the idea of this conference, and I really congratulate the principal of the college for the able leadership, under the leadership of whom this conference is being organized. And as you all know, the boundaries are fading, though the conference is being organized by the chemical society, or you can say chemistry department, but as research is taking interdisciplinary shape in all over the world, so the technocrats and the scientists from all the fields of scientific disciplines are joined here. On the behalf of the entire organizing committee, I welcome all the participants, all the honorable guests, invited speakers, eminent experts to this conference. And without taking much time, I would like to request the honorable chief guest of this conference to join us. But before I invite him for the inaugural address, I would like to introduce you all with him. What a personality he is, a career goal for all the inspiring scientists, for all the aspiring educationalists. Professor Eki Bakshi is with us. It's a proud privilege to have you with us, sir. Professor Eki Bakshi is the founding Vice Chancellor of PDM University, Bahadurgarh. He has been Executive Director of Tertiary Education Commission, Mauritius, during October 2013 till February 2015. He was selected for this prestigious position through an international selection. Prior to joining TEC, he has been Vice Chancellor of UP Rajarshi Tandon Open University. Professor Bakshi held the prestigious Sir Shankar Lal Chair of Chemistry in the University of Delhi for more than 2 decades, and was also head of the Department of Chemistry in the University of Delhi during May 2010 to August 2011. He has also been a visiting professor at GGSIP University, Delhi during 2007. Professor Bakshi has also served as director of the Institute of Lifelong Learning, as well as the Center of Professional Development of Higher Education of University of Delhi during 2008 to 2010. Professor Bakshi is also presently chairman of the National Resource Center of Chemistry of the MHRD, Guru Anangadev Teaching Learning Center of MHRD, and Center for E-Learning, all the 3 centers located at the SGTB Khalsa College, University of Delhi. Professor Bakshi has also been the member of the Standing Committee of National Mission on Education through ICT. He was the chairman of the National Science Digital Library, and he was also the chairman of the Content Advisory Committee for Chemistry for Sakshat portal of MHRD, Government of India. a double gold medalist and PhD of Delhi University. Dr. Bakshi did his postdoctoral training at the University of Erlangen-Nuremberg, Germany, with Professor J. Ladek, and at the Kyoto University and the Institute of Fundamental Chemistry, Kyoto, Japan, with Professor K. Fukui, the Nobel laureate who is, and Professor T. Yamabe. He has also been a visiting scientist at Tata Institute of Fundamental Research, Mumbai, and the Indian Institute of Science, Bengaluru. Professor Bakshi's research interests include theoretical polymer chemistry with special reference to electrically conducting polymers and biopolymers. Professor Bakshi is the author or co-author of more than 180 research and one author or co-author 51 ebooks as editor, chairman, convener of the working group, and 63 e-modules as author, co-author for PG Chemistry. He has also been a member of National Writing Team for Chemistry Class 11th and 12th books of NCERT. And to speak of the awards he has earned, the academic honors he has earned, the list is so long, but I won't like you to miss just because of the shortage of time. We have plenty of time. You must know how much can be accomplished in the field of academics and research if one is dedicated enough. Professor Bakshi has been recipient of several awards and academic honors. These include, amongst others, his Excellency Education Award 2021, International Public Figure Award 2020, Acharya Chanakya Shikshavid Samman 2020, World Education Award 2017, Haryana Ratan Award 2016, Bharat Jyoti Award 2016, India Didactics Association Special Award for Excellence in Digital Content in Education 2014, National Education Award by News Channel Headlines Today 2012, Biovid Honorary Fellowship 2012, Professor Ramdas Tiwari Memorial Lecture 2012, Dr. R.D. Desai Award of the Indian Chemical Society 2009, Professor P.K. Bose Memorial Award of the Indian Chemical Society 2008, Fellowship of IUPAC 2006, Member of World Bank Team for Kabul University in 2006, Distinguished Teacher Award 2000, Chemical Research Society of India Medal 2000, Fellowship of the National Academy of Sciences 97, JSPS Fellowship of Japan in 1995, CSIR Visiting Associateship in 91, INSA Research Fellowship 1990, UGC Career Award 1989, Best Paper Award in the field of Chemical Sciences from DAR Fellowship of Germany, Young Chemist Award 1983, Dr. Krishan Rao Gold Medal 1978, Professor R.P. Mitra Gold Medal 1973. So, consistency, that is the word that comes into mind when we read the entire list. Beginning from 1973, he has always been making the mark and he is continuing to make his mark till now. And the standard is raising higher and higher. So that's such a motivation for all of us, sir. It's really proud to have you amongst us. Professor Bakshi was felicitated 2 times in September 2009 and December 2011 for distinctive and outstanding contributions to education, including e-transformation of the University of Delhi by the former President of India, Dr. APJ Abdul Kalam. So, a great man honoring another great man. Professor Bakshi was elected as the president of the section of the Chemical Sciences of the Indian Science Congress Association for the year 2011-12. Professor Bakshi has been a member of the editorial boards of the Indian Journal of Chemistry and Journal of Scientific and Industrial Research, published by the CSIR, and also the chief editor of the UGC-sponsored journal, Chemistry Education Review. Professor Bakshi has also been a member of various professional and academic bodies, committees of MHRD, UGC, NAC, DST, CBSE, NCERT, various universities, colleges, etc. Last but not the least, Professor Bakshi has also the distinction of being one of the first persons from the universities or in India to have been selected as the member scientist of the third Indian research expedition to Antarctica in 1984. So woods are lovely, but I have miles to go before I sleep. That's the lesson we can learn from the Professor Bakshi's life. And the journey is still continued. We wish you all the best, sir, that you achieve even higher heights. And with this introduction, you must be realizing that the introduction was a bit too long, but it has not covered all the aspects yet. What a person he is! I personally know him. The modesty of his character, that would I like to mention in front of all of you. He's such a nice human being and always cooperative and very humble. And I really appreciate knowing such a person existing on earth, sir. Thank you so much for being with us. And now I invite you for the inaugural address, please.
Thank you very much, Dr. Deepa, for your very, very kind words of introduction. I am overwhelmed by your comments and introduction. Thanks a lot.
Welcome, sir. Welcome, please.
Good morning, everybody. Esteemed Dr. Satish Bhardwaj, Principal S.U.S. Government College, Matak Majri, Indri, Karnal. Professor Neera Raghav, Chairperson, Chemistry Department of Kurukshetra University. Dr. Suresh Kumar, Organizing Secretary of the conference. Dr. Gulab Singh, Convener. Dr. Deepa, she is Head of the Department of Physics. And dear participants from all over the country, maybe from international level even. It's indeed a great honor and a privilege to have this opportunity to inaugurate this two-day international conference on new trends in chemical research 2022 being organized by S.U.S. Government College under the aegis of Department of Higher Education, Government of Haryana. I really feel honored to have this opportunity to address such an august gathering which has assembled here. You know, when I was asked to deliver the inaugural address, there were many options open to me. But then since this is not the technical session, I thought, let me deliver a talk on a topic which will be really and which can be a game changer for all of you. This is entirely based on my experiences. So let me first of all share my screen. Dr. Deepa, would you confirm, am I audible and my screen is visible?
You are perfectly audible, sir. Your screen is also visible, very clear.
Thank you. Thank you very much. So, you know, this is the title of my today's talk. And I think this will be of interest to everybody, not only the chemistry people, but even others also. And the title is Need to Redesign Chemical Education in India for Excellence in Chemical Research in the 21st Century. And below that, I have written learnings from the ground. You know, this is what I have learned from my vast experience. So that I will share with you. And let me say it that this talk is based on my conceptualization and experience.
विमल राय ये दोनों केमिस्ट्री वालों संभालो अब नाम भूल गए कि देखो
Kindly switch off your mic, please. Everybody else except the honorable speaker.
So
Thank
this
you.
talk is based on my conceptualization and experience. The spirit behind the talk is to be good is no longer enough. One must strive for excellence. Now the question comes, why there is a need for redesigning chemical education in India? That could be the first question in your mind. You will all agree that chemical education is the foundation of chemical research. And chemical research is the cornerstone of the development of the nation. It plays such an important role in the development of the country. Now, let's look at our performance in chemical research or in general in scientific research. India has the third largest scientific and technical manpower in the world. Here you can see India is number 3 in scientific publications after China and United States, which is a big thing. But this was a report which was published in Times of India that out of the 4,000 most cited researchers in the world, only 10 are from India. That is 0.25%. And these are the people who are there, including Professor C.N.R. Rao. There is a book called The Scientific Edge, written by Jayant B. Narlikar, where he says that the 5 achievements of Indian science and technology in the first half of the 20th century were mainly due to these individual efforts of Ramanujan, Meghnad Saha, S.N. Bose, etc. But in the second half of the 20th century, the achievements of Indian science and technology were due to these government-funded organized science and technology projects, Green Revolution, space research, nuclear energy, etc. So he asked a question that why is it that in the second part of the 20th century, we could not recreate the magic of the early part of the century created by Ramanujan, Raman, Bose, etc. In India, I feel there is a dearth of creative minds. No Nobel Prize ever for an Indian chemist working in India. C.V. Raman was the only person who got Nobel Prize in 1930 for his discovery of Raman effect. And that was in physics. Then these people got Nobel Prizes, but then they were non-resident Indians. Please remember, Nobel Prize is not a lifetime achievement award. If you really want to excel in research at that level, you need 3 things: enormous amounts of creativity and open-mindedness. This is one. Second is you should be willing to collaborate. We sometimes prefer to work in isolation. That never pays. And then you should have perseverance and resilience. We sometimes also want immediate gains. That's also not possible. I remember about 2 years back, one Nobel laureate in chemistry, he was 97-year-old. So patience is also required, and you have to be very consistent in the work. Look at the field of electrically conducting polymers. We all know that. The discovery was made in 1977, and the Nobel Prize was awarded in 23 years later in 2000. And these were the 3 people who got Nobel Prize. Now look at the fact how this field started. You start with acetylene, you polymerize it, you get polyacetylene. Depending upon temperature, it could be cis polyacetylene or trans polyacetylene. But they are insulators. So this till that stage, it was a very simple reaction. But then they treated this polyacetylene with oxidizing or reducing agents. There was a sharp increase in conductivity. So that was the real turning point. And conductivity reached up to 10 to the power 3 Siemens per centimeter. So this was the initial breakthrough achieved in 1977. And then slowly the field expanded, new polymers were discovered, their applications were found out, and after well establishment in the year 2000, Nobel Prize was awarded to those three people. And now, electrically conducting polymers are already called as the materials of the 21st century. So you can see how this breakthrough was achieved. Another breakthrough you should know, for the last almost 100 years, people have been working on developing a material that could show superconductivity at room temperature. But this breakthrough was achieved only last year at the University of Rochester after almost 100 years. So again, it shows that you have to keep on working. Look at quantum mechanics. We all study, even physics people also and chemistry people. This is considered to be one of the greatest intellectual development of the 20th century. It provides the foundations of modern chemistry. And if you look at the development of quantum mechanics, at least 10 scientists involved in the development of quantum mechanics have won Nobel Prizes. These are the people. All of them got Nobel Prizes. So the development of quantum mechanics, surpassing classical mechanics is an example of how creativity can enable one to think much beyond what exists. That is the point which I want to say. You have to be highly creative. Quantum mechanics also, as you all know, provides the theoretical foundations of spectroscopy. With all what I have said, now our position needs to be examined. This is the ranking of our universities and institutes 2021. The top position is by IIT Bombay, 172, and the top position amongst the universities is of Delhi University at 501. So we are not in the top 100 even. And please remember, one of the main reasons for the poor world ranking of our higher educational institutions is poor quality of our research programs. There is a lack of research culture in India. Please remember, there have always been some peaks of excellence here or there. But whether they are because of the system or in spite of the system, that's the big question mark. That's why, in the new education policy, when it is said that we should create a national research foundation, it clearly mentioned that there is a need to foster a strong research culture and build research capacity in India. Our teaching is not for research, just for passing examination and getting a degree. And then our research capacity is low. Not many people come to research. Look at this. This is the number of research persons per 1 million of population. India is just 216.2. And you can see the comparison with China, USA, and even South Korea. So lack of quality research in higher educational institutions is mainly due to dearth of creative minds coming out of our education system. Please remember, when creative minds come together, they can make the impossible possible and the ordinary extraordinary. Creative minds can provide innovative solutions to the problem and start new trends in chemical research. This conference is on new trends in chemical research. In order to become leader in chemical research, we need creative minds. So, what's the fundamental flaw in our education system? You may ask the question. Nobody will think for us. We have to think ourselves. Where do we just watch this? This is about 2-minute video.
For decades, people have been finding hundreds of flaws in the education system. No conceptual understanding, no creativity, children are stressed, and the list goes on. All these are symptoms. But what is the root cause to all this? What is the fundamental flaw in the education system? Let us play a rapid-fire game. You have 1 second to answer every question. Let's start. First question. A4? Okay, no more questions. Did you think apple first? 98% of people are most likely to think so. Because that was what we were told in kindergarten. Imagine that this was done differently. Say we had asked you for all the words starting with A. Ant, ace, April, apt. Different answers would have popped out of everyone's head. Do you see where the problem is? Before children start going to school, every child is unique. Every child thinks different. But the education system makes every child think the same. This is the fundamental flaw in the education system. Why did this start? During the Industrial Revolution in the 18th century, the education system was designed to make children ready to work in factories. The factories did not require people to think, but to only work like robots. So, the education system stripped children of their freedom to think and destroyed their true potential. The same education system continues even today. Only the industries have changed. A study by NASA shows that 98% of children think different before they start going to school. As they go through this education system, at 25 years of age, only 2% think different, and 98% think the same. So how does the education system make every child the same? Let's go back to the apple example. Kindergarten lessons told us that A is for apple. We asked you for words that start with A. Our education system gave us the answers. We asked you a question. Answers make you the same. Questions make you different. Right from kindergarten, the education system keeps giving answers. Instead of asking children how plants make food, the science teacher gives you the definition of photosynthesis. Instead of asking them to describe the sun, the teacher tells them that the sun is a ball of fire at the center of the solar system. Through their years in school, children lose the capability to think on their own. Whether it is their choice of career or their relationship or any situation in life, they become.
So you can very well see how our education system stripped the children of their ability to think on their own. Our education system does not encourage thinking, innovation, and creativity amongst our students. And please remember, without creativity, there can be no progress. And we would be forever repeating the same pattern. It is the creativity which enables one to think much beyond what exists. This was my article in Times about the creativity crisis in the Indian education system. One should find that there is no dearth of talent in India. We have talented children. Only thing is that we need to nurture this talent. We need to sharpen their skills. That is the need of the hour. Look at this. Already, if you look at this fact, India is a well-established source of talented manpower. In United States, 5% are the medical doctors, Indian. 12% are the scientists in USA from India. 36% scientists at NASA are Indians. 34% employees at Microsoft are Indians. So, and even at Intel also 20%. So there is no dearth of talent. Only thing is we have to polish them, nurture them, sharpen their skills, and make them useful. And that is possible through education. And once you become creative, you can become innovative, then you can start an enterprise and all that. The root cause is creativity. Now, I would also like to mention here very briefly as to why the things are different in the 21st century. 21st century learning needs, it is said that in the 21st century, if you want to excel, you need two things. One is you should be very good in the subject. And second is you need 21st century skills. 21st century skills are a set of abilities which can help you, thrive and succeed in the 21st century. These come under learning skills, critical thinking, creativity, collaboration, and communication. Then literacy skills, information literacy, media literacy, technology literacy, and then life skills, flexibility, leadership, initiative, etc. These are going to be the deciding factor in the 21st century. You may ask the question, why these skills have become so important? Because, the way the world is progressing, those people who will have these skills, they will be able to do much better because you cannot have machines with these skills. Artificial intelligence is coming, but you cannot have a machine which is critically thinking. You can't have a machine with leadership quality. So these skills can be the deciding factor. And look at this. Already many companies all over the world are now hiring people with these skills. They are not bothered about degrees. They want skill set. And one more thing which I want all of us, because we are all teachers and we have to nurture our students. We should acquire, for ourselves also, we should acquire competence. So quality chemical education will be knowledge, skills, and personality is also very important. Disciplinary knowledge, interdisciplinary knowledge, and practical knowledge. Then 21st century skills, which I just mentioned. And the third thing is your attitude, your values, your traits, that comes under personality. These three things will define the quality of the education. And these three things determine the competence. Please remember, we should always focus on all the three things. Acquire competence. Personality sometimes we neglect. It plays a very important role for the success. There is a report that 87% of all people fail, not because of capability, but because of personality. But personality development is often neglected in our education system. So personality means a set of traits and behaviors that characterize an individual. It can be changed. Personality doesn't mean only your looks. Now I come to the second part. Whatsoever I've said in the background, now how to redesign chemical education in India. In order to redesign chemical education in India, one needs to focus on four things. What do we teach? How do we teach? How do we assess our students? And on the teacher itself. Curriculum, if you look at, curriculum basically means total learning experience. The problem in India is we have very heavy syllabi. Still, we have 11th and 12th system I'm talking about. Many outdated topics are there. We still teach those things which are very, very old. The result is that there is a gap between what is learned and what should be learned. And this creates a problem in research. There is no regular revision, no coordination between school education and higher education. And hardly any emphasis on skills and values. Teachers are, as a matter of fact, not equipped to teach skills. This is the problem in India's education system is we have 21st century students, but the subjects content which we teach is generally of the 19th century, courses architecture of the 19th century, and the methods of teaching are of the 20th century. This is, other day even Prime Minister also mentioned, we need to change with the changing times. New education policy also says, make syllabi light but modern. We must change with the changing times. Chemistry knowledge is growing very, very fast. If you don't change, you will be left behind in the race. There was a time when knowledge was doubling in 150 years. But now this time has come down to almost 73 days. So you can very well imagine how soon our knowledge is getting outdated. And please remember, in any part of the world, what we know is a drop and what we do not know is an ocean. This is the reality. Look at this. Chemists produce in the laboratory, and the number of chemical substances is increasing. Look at this. In year 100, 1800, we have some hundreds of chemical substances. Today we have about 80 million. And by the end of this century, we will have 5 billion chemicals. Then number of elements in the periodic table has increased from 63 to 118. So this is another indicator of the growth of knowledge. There is a growth of new and modern instruments. So research activity can change. And then many new concepts, theories, and ideas are emerging on the chemistry scene. We sometimes, I feel, I have been in this system for a very long time. Joining lecturership in Delhi University just at the age of 21, I have seen closely, and even at international level, we are still teaching outdated topics. Rather, those should become a part of the history of science now. Because of this growth of knowledge, these used to be the traditional branches of chemistry, you all know. But now, many new sub-disciplines of chemistry are emerging. All these are the new areas which have emerged because of the growth of knowledge. And the list is growing day by day. And this, growth of chemistry knowledge has led to the diversification of research areas. These are some of the thrust research areas in chemistry. But this list cannot be complete because so much is happening. You just can't put it in a slide. And some of the new trends in chemical research all over the world include sustainable chemical production. Green chemistry plays a very important role. Now, artificial intelligence and machine learning are coming in chemistry. Retrosynthesis has always been a very big step for planning organic synthesis. Recycling batteries are coming. Blockchain technology is coming. Chemiluminescence is coming. Nanosensors, superwettability, and high pressure inorganic chemistry. These are some of the new trends in chemical research. But are we equipped for these? That's the question. Please remember, we need to revise and modernize chemistry syllabi more frequently. Our syllabi should become skill-based and industry-led. We need to have inputs from the industry. And this revision should begin from school level onwards. Otherwise, nothing will happen. I feel it, I'm convinced. Then second is pedagogy, how we teach. We still, teaching is the most important component of the education system. Our method of teaching is still talk and chalk method, teacher-centric approach. Still focuses on examination, rote learning, and scoring high marks. We do not encourage thinking, etc. This is today's reality in chemistry. Nobody wants to learn the concepts. Everybody wants 90 plus marks in chemistry. The student's mark sheet has become a prestige sheet for the family, but a pressure sheet for the child. And then experimental work is of poor quality, too many compartments. We need to build more bridges rather than walls. Look at this. Science is a systematic study of reality. Different branches of science, physics, chemistry, botany, zoology, they are dealing with that part of reality. It is a man-made compartmentalization. So this is a central science. We have to tell the connection, as I think Dr. Deepa was also mentioning. We need to focus on interdisciplinarity. We need to follow an integrated approach to teaching and learning. We should not teach subjects in isolation. And now the problem is sometimes people say, oh, I am from physical chemistry, I do not know organic, or I am from organic, I am not much conversant with analytical or something like that. That will not work. Its interconnection has to be established, because it is most of the researches in the world are of interdisciplinary nature. For example, just while I was preparing, I made this slide. We teach all these 4 subjects: quantum mechanics, statistical mechanics, spectroscopy, and thermodynamics. And sometimes we teach them in isolation, as if they have nothing to do with each other. But in fact, they are all connected. Quantum mechanics is a theoretical study of microscopic matter. For microscopic matter, dual behavior is important. We solve Schrodinger equation and we get the properties of the microscopic matter. We call them observables. Statistical mechanics is a theoretical study of the bulk of the matter. In quantum mechanics, you will study 1 atom. In statistical mechanics, you will study maybe 1 mole of atoms, bulk. There it was the wave function. Here it is the partition function, which is the storehouse of information. Now, in quantum mechanics, the results which you get, they are experimentally verified through spectroscopy. Just see. And in statistical mechanics, whatsoever results you get of the bulk of the matter, those are verified through thermodynamics, which deals with the bulk. So there is so much interconnection. This is what we need to do in our teaching. We need to devise also activities that challenge the student's mind, enhance creative thinking, engage the learners, and improve analytical skills. See, I don't have much time, but I just want to convey it to you that this is the need of the hour. Please remember, learning is not the product of teaching. Learning is the product of activity of the learners. Engage the learner. They will never forget it. Look at these top universities of the world: Harvard, Stanford, Wharton. Most of them focus on case studies, project-based and problem-based learning. And there is less emphasis on lecture-based learning. We still focus on lecture-based learning. In 1 week, lectures or 16 lectures like that. We have to change with the changing times. Now, for example, flipped classroom model is becoming very popular all over the world. Here, a teacher will create a video lecture and share with the students. Students will watch the video lecture at home, watch it 2-3 times, and then they will prepare questions for the teacher. And then at the school, teacher will facilitate discussion and will answer students' questions. And student will ask the questions and participate in learning activities. So here, through this flipped teaching, you can promote higher order thinking skills amongst the students. Another thing you have to keep it in mind in the 21st century is technology you cannot leave, and it has a very important role to play in chemistry education. See, it's difficult to imagine chemical education without technology in the 21st century. Look at this. This is just what happens in 1 minute on internet. I can't read everything, but I just say 500 hours of YouTube content is uploaded in 1 minute. 21.1 million texts are sent. 1.4 million scrolling on the Facebook. And you can see. Technology is there all around us. But technology should be used strategically to benefit the students. Because it is now being felt that excessive use of technology has impacted adversely the creativity of the students. For everything, they depend on technology. Even students and teachers have forgotten the art of writing by hand. They are using keyboard and that all basically. And it affects your motor skills. And because of technology, you will all agree that education and chemical education has changed. This is what I could prepare. How chemistry education in the country and even in the world has changed because of technology. E-learning and MOOCs are coming digitally. Experimental work, you have virtual labs. You can revise syllabi quickly through e-learning, through emails, discussion forum, etc. Research, because literature is growing very, very fast. So you have electronic databases to help you. Assessment you can do through online examination. There is already national testing agency in the country. Professional development. Now, earlier there used to be refresher and orientation courses. Now it is done online through SWAYAM portal. And then new methods of teaching have come, ICT empowered pedagogies like flipped classroom, experiential learning, project-based learning. Just see. But please remember, technology is only an enabler. Technology can only achieve the vision of the person who is using it. Technology doesn't have a brain of its own. So this is something it can only save your time. Brain has to be you have to be creative. You can save time by doing all that. And please remember also that technology in education is a journey and not a destination. Technology is changing. We had 1G, 2G, 3G, now 5G is coming. Even pedagogies are changing. Chalk and talk method, e-learning, blended learning, and now in future, personalized learning is going to come. Personalized learning basically means what? Every learner is unique. Every learner has different needs, different comprehension rate, different learning capacity. So you find out the strengths and weaknesses of each learner and then use learning analytics, basically, and then propose a curriculum for each individual. So every individual will have a different curriculum depending upon his or her strengths and weaknesses. Gamification is coming in chemical education. Gamification basically is based on gaming concepts, that is competition, incentives, and goal attainment. Already many e-learning games are available where you can learn so many things of chemistry much better. Visually, visual impact always has a greater impact. These are some of the e-learning games for chemistry learners. These are some of the video games for teaching, learning chemistry, well known. So you can see, my purpose of saying all this is how education scenario is changing. And if out of this education scenario, we have to come out with excellence in research, we have to be really very bright. We have to work. Even our assessment needs to be changed. New education policy has specially mentioned transform the culture of assessment, because assessment drives learning. The way you will assess your students will start learning in that way. You ask them rote learning, they will do rote learning. So it can be a good way to enhance quality of education. Assessment process needs to be made more scientific to encourage multiple skills of the students. But for that, teachers need to be equipped. They should know how to assess students. It is said learning is a 6-level hierarchy. Anything you learn, I'm talking about cognitive learning, it starts from remembering, understanding, application, takes you to creativity. So your assessment should test the higher order thinking skills. But then who will develop the questions? It is the teachers. So our education system does not bring out the real ability, achievement, or potential of our students. Our teachers are generally not equipped with a deep understanding of how children learn and how to assess a child's overall growth. We lack that. We examine children one against the other, I would rather put it. So we have to know the science of learning. Question in exams need to be on concepts, critical thinking, analytical thinking, and various ways of looking at the avenues of knowledge, not just the speedy reproduction of information, as is the case in Kaun Banega Crorepati. And lastly, the pivot of the education system is teacher. Please remember, the quality of an educational system cannot exceed the quality of its teachers. If you want to enhance the quality of an educational system, you must raise the competence level of the teachers. These are the traditional roles of the teacher: teaching, research, administration, and management. But now in the 21st century, the roles of the teachers are going to change. They need to be tech savvy in ICT skills. If students are enrolled in e-learning or MOOCs, if they have some queries, who will answer? It is the teachers. So teachers must learn how to manage virtual classroom and discussion forum. So they should also learn how to engage students by learner-centric methods of teaching. So teachers will become now coaches or mentors rather than knowledge providers. They should also be proficient in the development of e-content and MOOCs. Writing skills should be excellent. There are many teachers who have been teaching a paper for many years, but when you ask them to write, they are not able to do because that writing skill is missing. What I would like to say, dear participants, that a change of mindset is required in the country. What I know is enough, that's not going to work. I must learn more. Whatsoever may be your age, you have to be interdisciplinary in your thinking, upskilling, and learning other subjects. And once we are the role model for our students, then we will be able to produce creative minds. So the ultimate roadmap for redesigning chemical education is have light but modern syllabi, regular revision. Knowledge is growing very fast. You keep on revising the syllabi. Proper coordination between school and higher education, regular professional development of the teacher, not one refresher or one orientation. That will not work. It is a professional development should rather be a journey. Continuously keep on doing that. Then motivational lectures should be there for teachers, how to excel in their career. They have also their own career. They should be encouraged to adopt new teaching methods. Flipped classroom, learner-centric approach, experiential learning, collaborative learning, etc. Focus should be on teaching concepts, skills, etc. Every individual has a creative potential. We should do our best to make that come out. Then students should also be trained through problems of different difficulty levels to help them acquire conceptual clarity and in-depth understanding. We need also to transform the culture of assessment in India. And teaching profession should be made more attractive. Best minds should come to the teaching profession. You are building the future of the country. Nehru once said that the future of the country is built in the classroom. Then teacher education is also required. If we look at the recruitment of the teachers, you have PG, PhD, NET, but whether the person is able to teach well, nobody tests. So now there is already a discussion. We should have a few months course on teacher education, how to introduce a topic. There are many teachers who are full of knowledge, but they are not able to convey it well. Then there should be good promotional avenues. Excellence in teaching should be rewarded by the national level awards. I don't think there is any national level award for excellence in teaching in physics or chemistry or anywhere. Fellowship of the prestigious science academy should also be to the people who have excelled in teaching. So teachers should also become tech savvy. So the message is excellence in chemical research is not possible without quality chemical research education. I have told you where do we need to improve. Once we do this, then only we will be able to produce really creative minds. We should be leaders, not followers. We all teach chemistry. Just notice sometimes while teaching chemistry, how many times we come across Indians' contribution while teaching chemistry? Not much. So where do we lack? This is the problem. Because I have worked closely with a Nobel laureate, I have seen how things work. And it doesn't happen overnight. It is said, life is a process. No one rises suddenly in the world, not even the sun. It will take time, but we should be on the right path. Strategy is required. These are the challenges before us. And before I close, there is a quote, a ship is safe in harbor, but that's not what ships are built for. So humans are not designed to be happy in status quo. So please continue to remain dissatisfied so that you can get better and better. Challenges are what keep us fresh. You should have this principle both at work and in life. Don't take every challenge as a problem, take every problem as a challenge. Thank you very much. It was a pleasure talking to you, and thanks for giving me this opportunity to share some of my thoughts. And I once again thank the organizers for this wonderful opportunity to share my views with you. Thank you very much.
Well, thank you, sir.
Thank you.
It was such an enlightening guidelines for us teachers. We have to be very creative. We have to encourage students to think out of the box. And the tools you have provided, they will not only redesign the chemical education, but they are useful for us, the faculty members of all the disciplines. We will redesign our teaching methods also. So thank you so much, sir.
Thank you.
And if you allow, I would like to add some comments.
Sure. Please.
Yeah, one thing is that you mentioned that no one has been awarded Nobel Prize in India in chemistry so far.
While working in India.
Yeah, while working in India. I would like to add to that, but Professor C.N.R. Rao, he has been nominated thrice. Somehow he has not reached the final platform. So
there are many who have been nominated.
Yes. So our worthy colleagues should be knowing that we are striving for that position. The only thing is somehow we miss at the final point. And another thing that you mentioned that we don't encourage the original thinking. We rather snub students who are thinking out of the box. I would like to mention here that once my son, in the fill up for colors name, he wrote Kala Akash. And not only the teacher, but even I said, ki ek number kata diya. And when he asked ki at night, so I was surprised ki his thinking was much broader than ours rather. He was thinking beyond boundaries. We have limited our thinking rather because of being in the system. So I would like to suggest all my colleagues who have joined here that please encourage students to think out of the box. Not only black, let's allow the teachers to have the sky pink even. So if they feel so, then thank you so much. We will held your lecture, many of things in your lecture as the torchbearer to us. Thank you so much, and we are really proud to have you amongst us, sir.
So nice of you. Actually, I took this title because I could have spoken on my research field.
Yeah.
But I thought this is more fundamental. This is the need of the hour.
Exactly,
Because
sir. Exactly.
We should not try to treat the symptoms. We should go to the root cause where the problem is. That's why I wanted to share this.
Yeah, perfectly agree, sir. Perfectly agree with you.
Thank you.
And it's been really very much informative as well, very much motivating as well to us. Thank you so much.
Thank you, and thanks Gulab Singh ji also for giving me this opportunity. It was a pleasure to speak at this platform. Thank you very much.
Thank you, sir.
So it's now my time to deliver the vote of thanks for the inaugural session. So I would like to thank the Department of Higher Education, Government of Haryana, for the kind patronage of the department for granting us permission. Then I would like to thank our Honorable Principal Sir, Dr. Satish Bhardwaj, for his motivational leadership. He has been very much encouraging during the course of organization of this conference all the way through. Then I would like to thank the chemistry department of the college that they conceived the ideas and they pulled it through. You really deserve heartiest congratulations on part of every one of us. And we look forward that this conference goes a big success. Then I would like to thank, we can't miss the technocrats and scientists who have given us this digital platform through which we are all interacting in spite of being miles apart. So I'm thankful to Google for providing us this Google Meet platform. And I'm thankful to all the subject expert, honorable eminent speakers who are with us today and who are going to make a great contribution to the success of this conference. I'm thankful to all the participants. They are who make the conference a real success. I'm very thankful to you for your zeal to participate and for sparing time to be with us. And I'd like to thank the media persons who are going to give in anticipation a due coverage to this event so that the messages travel to the more higher, broader masses. And last but not the least, I would like to thank all the technical team, all the intellectual team, the organizing committee of the conference. You have been putting in your best efforts and you have come up with flying colors and all the during both the days. I know it's going to be a success. I have no doubt about that. Thank you very much, everyone.
Thank you.
With this, the inaugural session and now for the next session, I would like to welcome the keynote speaker, Professor Neera Raghav amongst us, and the chairperson of Shivpi Singh and Dr. Jain Sindhu, Dr. Virender Singh are all present with us. These are eminent personality of the chemical world. I welcome you all on this platform, please. And now, before we move on to the keynote presentation session, I would like to introduce you to Dr. Sudhir Kumar, who is professor in the Department of Molecular Biology, Biotechnology, and Bioinformatics in the CCS Haryana Agricultural University, Hisar. Dr. Sudhir Kumar was born and raised in holy city of Kurukshetra, and he has earned his BSc in 1982 and MSc in 1984 from Kurukshetra University. He worked as UGC JRF with Professor H.K. Pujari for his PhD degree in synthetic organic chemistry from KU Kurukshetra. After a short stint with the then Ranbaxy Laboratories, he joined the CCS Haryana Agricultural University as assistant scientist in 1990. Kumar sir has been a Boycast postdoctoral fellow to Boston Advanced Research Center, TX USA, and under the supervision of Dr. R.S. Verma, he did his postdoc. He was elevated to the post of associate professor and then professor in 2007. So Professor Sudhir Kumar, he is a chemist by training and was instrumental in starting the discipline of bioinformatics in his university in 2004 and still continues to work in bioinformatics as well as chemistry. He has many publications in reputed journals throughout his career, and he has been INSA visiting fellow and MHRD lead trainee. He has served at various administrative positions in his university. So we have this profound personality with us, and he will be chairing the session, the next session. So I would like to hand over to you, sir. Kindly take over.
Good morning, everybody. Thank you, Dr. Deepa, for introducing me in such words, which I don't know really whether I deserve or not. The first session, as told already, belongs to Dr. Neera Raghav, who will be the keynote speaker. Dr. Neera, can you come on the video, please? Dr. Neera. Hello, good morning, Dr. Neera.
Good morning, sir.
Good morning, welcome. So it's my pleasure to introduce Dr. Neera Raghav to all participants in this conference. Dr. Neera is presently heading the chemistry department in prestigious Kurukshetra University, which happens to be my alma mater as well. She has with her around 27 years of experience in teaching and research, and she has been instrumental in establishing various facilities in the Department of Chemistry. Before joining the Department of Chemistry, she has some experience of teaching in Guru Nanak Khalsa College, Yamunanagar as well, for 9 or 10 years or so. Dr. Neera has published more than 50 research papers, very good quality research papers in various journals of national and international repute. So I hand over, Neera, to you. Please, you can start. And for participants, if you have any question, please raise the hand. We have a facility in raise the hand in the Google Meet, or in the comment box you can write. I'll try to watch everything, and at the end of the session, we'll ask Dr. Neera to reply few questions, if not all, because we are already running a little late of time. Is that fine with everybody? Okay, thank you. Dr. Neera, mic is with you now.
Am I audible?
Yeah. I heard you for a while, but then
Okay.
it went off.
I'll
Yes.
request the organizers to please unmute my laptop, the second thing that I have joined with, because I'm not able to unmute myself.
Okay, the technical team, can you help? Dr. Neera has two connections. One is with the laptop and the other one is separately. Please unmute both.
Sir, technical team is resolving the issue.
Okay. Dr. S.P. Singh, good morning, sir. Dr. S.P. Singh, good morning, sir. Sir, Sudhir बोल रहा हूँ, Sudhir.
It's already updated on this side.
Okay, sir. Thank you.
Good morning, sir.
Out of the box, then then there is no hindrance in your work. So I just wanted to share my journey of research, because Bakshi ji has already told that what should, as a researcher, as a chemist, we should do. He has already mentioned all the important points which we should take care of. So I would like to share some of my work which I have done. Not I have done, my research students have done. And you can see from where I started. The title of my talk is Connecting the Dots, because that I had to connect the dot from where I started my journey. I worked in the field of enzymes when I was doing my research. Is it visible?
Yes, ma'am, it is visible.
Okay, thank you. So, as a chemist, I did my MSc in chemistry, and then I joined research under the supervision of Professor Hari Singh. He was doing the work in Department of Chemistry, but he was working in the field of enzymes, the purification of enzymes. At that time, to establish that lab was very difficult because there was very less funding. And in that, what we have to do, we have to purify the enzyme, we have to run the columns for 2 to 3 days and night without any intermittent breaking in the column, because they have to be run continuously. And then when I joined research in 2006 in the department, and I joined the department and I had to pursue research, then I thought what to do. Because I knew about the enzyme purification, I was not aware of the synthetic schemes. There was a lag behind between my college teaching, and there was a gap of 11 years. So I thought that why not synthesize the simple compounds and see their enzyme inhibition behavior. So with this motive, my first research scholar was who joined with me was Dr. Ravinder Kaur, and she is now in teaching in pharmaceutical chemistry in the department. And she did very small synthesis. As you can see, that what we were doing, we were just synthesizing the semicarbazones and thiosemicarbazones of this benzaldehyde molecule. So these you can prepare very well in your college. These are the derivatives. I don't think that in the preparation of these derivatives there is any hindrance. But what was the new in it? We just added these compounds. We just reported these compounds as cathepsin B inhibitor. And these cathepsin, what are these cathepsin? I worked in my PhD on the cathepsins. We have purified the enzymes there. So there we related the synthesis of the small compounds. So these are simple semicarbazones and thiosemicarbazones, which are the derivatives. And we could publish it into the MedChem Research Journal. And I think all of you are aware that it is not a bad journal to publish in, having an impact factor of 1.8. So my purpose of showing my work is that you be in college or in university, what you have to do, you have to try to excel in the best suitable infrastructure available with you and give your best. This is what I had done and I am trying to do. So this is why we could succeed, because I tried to work in an interdisciplinary area. Like Dr. Sudhir has done, he has done a great work in bioinformatics. So this was the starting thing. And then we introduced some of the molecular modeling in our later work. Then the same candidate, again, this is the similar small molecules, chalcones, they are semicarbazones and pyrazolines. We reported them as inhibitors of cathepsin B, H end. Here again, you can see that it is a very simple scheme. Just we have to synthesize the these chalcones, and you can see that the R group. What is this R group? It is just simple ortho meta para chloro substitution, methoxy, nitro, and the parent compound, that is benzaldehyde. So with these simple molecules, we have derived these structures. There are these compounds, pyrazolines, and these semicarbazones. Again, what was the novelty in the molecule? These two, which you can see that as 2A and 2J, here 2A prime and 2J prime, there is no much difference between the structure. Just we could find that we were observing two peaks, two different spectra, mixed spectra in the NMR. So from there, we found that there is a difference in the configuration. One will be cis and the another will be trans, and these lone pair, they will be affecting the structure, and therefore we are having two different spectras. Although these are very simple compounds, they have been reported many a time before us, but none of the previous workers, they could identify two different these semicarbazones, the configuration of these two different semicarbazones. So this was the major thing that we observed from this simple molecule, and we could publish it into International Journal of Biological Macromolecules. These things, because I am aware about the organic chemistry, so these things, those participants who are listening, who are from the organic background, they can see that this is just a very simple condensation reaction. First is the Claisen-Schmidt condensation, and then again that is also a condensation reaction. So what was important in it? It was just the identification of two different configurational stereoisomers. Then another important thing was in the journey was that when we were discussing on the chalcones, there was 2' substituted chalcone. In this 2' substituted chalcone, what we could find that here there was a hydroxy group here, and then it led to the synthesis of coumarin derivative. So we could find that in presence of BSA, that is just a simple albumin protein, we can catalyze the conversion. We can convert 2' hydroxychalcones to flavones. So simple observation and simple things in the simple molecules led to the publication again in International Journal of Biological Macromolecules. So it is not that why are you equipped with a good facility? That is certainly very important. But if you do not have, then should you be demotivated, or should you say to anyone else that please include my name in your publication so that I may get promoted? No. One must go ahead with the available facilities and pursue further research to contribute to the honesty, to the with the honesty to the institute, because your work is going to help the institution grow. And it is not like that कि आपका जो idea है that will not be entertained by the funding agencies. There are people who are really doing good jobs. They are getting funded. They or initial level पर अगर आप try करें तो you can get seed money for the establishment of the lab also. Am I audible? There is some disturbance, I think.
Go ahead, Dr. Neera. You are audible clearly to me, at least.
Then there was another simple compound. Then because cathepsis, I was working on cathepsis. I started with working on cathepsis, but the substrate was very costly. So we have to look for the alternatives that those enzymes should be targeted where the investment should be lesser and should be easily available. Then my lab shifted toward to explore phosphatase inhibitors, and you can see here the synthesis is very small, very easy, just a condensation reaction with this substituted aryl aldehydes, and we condensed with the bis chalcones and synthesized bis chalcones, and then studied them as inhibitors of acid and alkaline phosphatases. These phosphatases, they are very important, and what we use to have liver function test, जब हम कहते हैं SGOT, SGPT, they are the phosphatases, and then these things came into existence in my lab, that other enzymes which are having low cost substrates, they should be targeted because everyone need to grow. We have to establish a lab, we have to train the PhD scholars. So there was this shift. Then again, there was an extension of the work, and that was published in European Journal of Pharmaceutical Sciences. I would like to mention here that all the work that we are doing in our lab, that is independent work, not in collaboration with anyone. Because I could do it because I wanted to work in the field of interdisciplinary work, enzyme inhibition studies. Just it is not a big job to do enzyme inhibition studies. You have to look for a enzyme which is suitable, which is important from a pharmaceutical point of view. And if you are able to develop good inhibitors, then you will be able to publish in a good journal. But your selection of enzymes should be very good. So then again, the same candidate, the second candidate, which registered with me, now she is Mamta, Dr. Mamta Singh. She is working in a school. So she was, another paper was published in EJMC, European Journal of Medicinal Chemistry. And you can see here what she did. Just a simple molecule. She prepared hydrazones again with the orthometapara directed substituents. And then with excess of hydrazine, she was able to synthesize various triazoles. So as you can see, very simple molecules, but again, they were the inhibitors of very potential enzymes which are involved in inflammation disease, which are responsible for the invasion and metastasis of cancer. So enzymes are important, molecules are simple. So we need not to synthesize beautiful motif containing compounds for good research to be published. My purpose of talk is not that that I am doing very good research. My purpose of the talk is that with the limited scope of facilities, if we are determined to do something good, we can surely achieve that. And as Dr. Bakshi has said, that you should have a proactive personality, and with your knowledge and the skills, you will be able to do. You will be able to achieve what you want to. Though my journey has not stopped, so I don't think that you are getting bored.
No, ma'am. Yes.
Okay. Then these are related to the similar type of compounds, simple compounds with the cathepsin inhibitors, and we synthesized. What important thing was in this study was that we tried to have orthometapara substituent so that we can give a proper structure activity relationship in our publication. So this is what is missing in most of the synthetic communications and synthetic publications, because what people do, they try to synthesize whatever is available. If you want to have a proper structure activity relationship, all of us know, because we all are have done, most of us have done PhD, doctorate hai. It's for structure activity relationship, you should have a proper orientation of the molecules. So if we have that, then we can conclude our results in that sense. And we can also do QSAR studies also, that is now computer based, and probably Dr. Sudhir can throw more light on that, because he is doing bioinformatic work on the bioinformatics, that how much significant these orientations are when we study biological interaction between the ligand and the biological molecules. And most of the work was things were achieved, that enzyme inhibition, I explored enzyme inhibition, and then there was the time to switch over. And what I did, I tried to explore Ayurvedic products. And one compound we selected was the curcumin. That is very important. And Indians were keen enough, CDRI Lucknow ki wajah se we were able to revoke the patent that was filed by US. And we had provided approximately 36 documents that this is our traditional heritage, and this patent should not be granted. And it was finally, we succeeded in revoking the patent of the curcumin. So this, I also started to work in the curcumin, because though it is a very controversial molecule, whether it is of therapeutic interest or not, whether it can be treated as a medicine or not, but still, more down, if you have a single click on Google, you will find that more than 27,000 publications immediately link करता है कि इतना जो है research जो है that is on the curcumin. So I also started on this, and what we did, we just simply studied and trapped the curcumin formulation which we are using in our daily life, with the curcumin, with the turmeric, with this fat, milk, and the sugar molecule, and this a small amount of black pepper in it. And you can see that we have studied the serum protein protecting activity and anticathepsin activities of curcumin formulations was enhanced approximately 200 times. So it is increasing the solubility of curcumin, and we published it into the Bioorganic Chemistry. And this is the work that has been published in 2020. And an extension of that was that because we were entrapping the formulations in the alginate hydrogels, so we studied the sustained release them as a sustained release systems to see the effect of traditional excipients. This was also published in the same Bioorganic Chemistry in the next year, subsequent year, 2021. The third thing which I would like to focus on, that because with the time we have to change our field. If we are a good synthetic chemist, we change the field to explore different structural motifs with the different pharmacological activities. We combine the two, and then we pursue our work. Because my work was mainly related to the biological systems with the enzymes. So what we next did was that we studied the hydrogels formation and the drug delivery systems. And this is the new field in which my students are doing research, and they are developing sustained release systems for curcumin, for non-steroidal anti-inflammatory drugs, and various other natural products. And presently we are working on piperine and this cinnamaldehyde. So as well said by Bakshi ji, that we must change our way of thinking. We must think out of the box, and some new things should be there, not to have good publications, but to have a good biodata, and not to restrain ourselves toward and curse that why we are selected here, why we are not in a university, we possess this much merit, but we have to explore ourselves. we have to do good in whatever area, whatever field we have been placed by the Almighty. So this was the new area, and I'm recently we have filed 4 patents. Just filing here, not a good thing, not a big achievement, but at least we have started filing, started thinking of filing the patents. So 4 patents have been filed last week, and because Department of Chemistry, Kurukshetra University is celebrating the patent week, and it was in news. And one more area is there that where one of the student is working, and he is also published in International Journal of Biological Macromolecules, where we immobilize the enzymes on the cellulose derivatives for the industrial application. So this is how you can relate your work to the industry, to the technology. Basic chemistry can always be a part of technology. This was what I wanted to say, that there should be no inhibition of the facilities. There should be no inhibition of working. If you want to do something, you will certainly be able to achieve it. This was my small journey of last 12 years. And this was what I wanted to share with you, that now if you want to propose some project, because you must include, because you have to send a proposal, you have to include word nanotechnology in your project, because nano is everywhere. You have to include sustainable development in your project, because that has to be there. We all are now organizing conferences. We all are having this types of platform where we have discussions, where chemistry can be a part of sustainable development. The goal number 2 is obviously of the chemistry. Goal number 6 is of chemistry. Goal number 9 is of chemistry. 7 is related to chemistry, where we are trying to entrap solar energy, clean energy, water, and this wind energy, and we have to synthesize, we have to entrap that. So it is more or less related to technology, where chemistry being a part of physics. Then again there will be interdisciplinary area. So these we need to explore and then submit the proposal like this. So surely maybe 1 or 2 failures, initial failures may be there, but then your writing skills, as Bakshi ji has said, that writing skill is very important. So if you are able to propose a good write-up, you are able to give a good write-up to the funding agency, at least they will be feeling somewhat why we are not including it, why we are not giving this, because he or she has given the best of the proposal. There are other things also that ifs and buts तो हमेशा रहते ही हैं, but still अगर आपको कहीं पे आपका प्रपोजल कहीं रिजेक्ट हो, उस समय ना मिल पाए, पहली बार में सक्सेस ना मिले, तो कम से कम जो आपको आपके प्रोजेक्ट को डिस्कार्ड कर रहा है वो कहे तो सही कि नहीं इसमें दम तो था. So then there is so now education is also being this goal number 3, that is good health and well-being. It is also a part of chemistry. Without chemists, without agriculturalists, we cannot achieve this thing. And this is again related to that. And then there is wind energy, solar, and so these are the various areas where you can explore, you can deviate your research, you can propose a project so that can be accepted. You get money for your college, for your lab, establishing your lab. And now one more thing is that there OLEDs are there, that organic chemists can synthesize these organic polymers, and that can give rise to various, so maybe you will be able to synthesize a good device, good material for this conversion of the energy. And this is just, I think I must switch over these slides, and where we have this green energy, green and sustainable chemistry. You can see that there are various targets which the sustainable development is going to, with this, we want to achieve with this, and there is no doubt that chemistry is involved in it. And sustainable food, because we want to have a pest management, and we have to have non-chemical alternatives for the beneficial agricultural practices. And here there is one emerging area that we can synthesize different aggregation pheromones which can be used for the pest control, and we may not have to use the insecticide on the crops as a whole. Just place the pesticide with the aggregation pheromone, the pests will come to that point and then they will get killed. So we can look upon these areas, and very important thing is that नेक्स्ट लेक्चर आई थिंक डॉक्टर सुधीर का है, तो आप एक बार इनसे जरूर बात कीजिए, क्योंकि जो हम कहते हैं आर्टिफिशियल इंटेलिजेंस इन केमिस्ट्री, this is one of the major thirst area in which chemistry people are doing great job, and you need not to have a synthetic lab for that, you need not to have equipments for that. All you need is your laptop, a computer system, and some softwares where you can go for molecular simulation, some sites which you need to be aware of. I'm having a weak hand in that, so I will not be able to throw light or more on that. So that can be explored, because more and more theoretical chemistry is being coming up, and that is not only that has become the basis of synthetic chemistry, that you need not to do different experiments. You can just optimize your reaction conditions with the help of software and then do good. We will also use that in the preparation of our gels. And the department में और भी बहुत सारे काम हो रहे हैं on the while standardizing these reaction conditions. So that can be explored. One of the very good area where facilities are not much required, and then for most of these things, then you will need a wet lab where for industry, sustainable industrialization, maybe that is good for college industry relationship, university industry relationship. But again, if we need more lot of funding from the industry, we have to prove our worth to the industry, that if industry is going to pay for that, we will be giving them some good results. And here where we chemistry people are very much related to this industry, because we are the persons who are polluting water, we are the persons who are polluting the environment, and we are creating non-degradable waste, because we create such type of material which is non-degradable, and later on it can bring chaos to the universe and to the Mother Earth. So better we now change our way of research, we change our needs to more natural friendly products. So this was I want to communicate that in transport also we need to have clean mobility and sustainable chemistry solutions for the batteries. Then in tourism, how can we relate chemistry with the tourism? No, we can relate chemistry with the tourism, because a tourist need to go from one place to another, need to have various fuels, and if a natural fuel is available, if a fuel that is having a low carbon footprint, then that will be a better solution for development of tourism, for establishing various tourism places. Then we have in case of mining, also we need to use natural resources, because what we are doing, we are just utilizing all the natural sources, and then what will happen when they will get depleted? So we need to convert, we need to explore areas where one material can be converted into another, with one that can be once used, it can be recycled. So these types of things we have to think upon. And certain things are indirectly related, that is the target, that is 8 in case of labor, where enhance the risk of assessment of chemicals, that promote the investment in green and sustainable chemistry to reduce hazardous occupational exposures. Obviously, the labor class which is working in the mines or various other places, even in this, when we get our house painted, then the fumes, what arises during that, we are using various liquors, and then those fumes, they are inhaled by the workers, and it is obviously affecting their life. So these things we have to work upon to create various green alternatives to the existing harmful chemicals. So here we can do it. And then in education, we need to develop various curricula, so that we can direct our chemistry toward the newer system, and we can educate new upcoming students that these are the solutions away from the hazardous things. These are the greener solutions. So those greener solutions should be the part of the curricula, and the students should be motivated to take up those courses. And then finally, when they will initiate at the school level, that will go to the college, and ultimately in the university and research, and finally to the industry. Greener solutions will be there, and as chemists we will not be we will be able to do good for the nature and provide best solutions, because we have to give the solution to the world, but that solution should not be harming the nature. That should be a positive solution for the world. I think I have taken enough time. It is 11:25. So what I wanted to add, that there are some things that was important. That if we are not able to synthesize any green, we are not able to provide any green solution, then the thing should be that we should to do such type of materials that they should be recyclable, and then they should be biodegradable, and if nothing can be done, they should be interconvertible. So with these words, I think we chemists available here, including myself, will be looking our research, we will be looking our goals toward in these directions. And thank you all for listening. Any other questions, please?
Thank you, Dr. Neera. We can take a few questions if there are any. The audience can raise hand or write in the comment box. I'll prefer that they turn their mic on and speak. Any participant? Any question?
Good morning, ma'am.
Good morning, Payal.
Ma'am, I want to ask one thing.
Yes.
That how to do enzyme selection for a particular compound.
You want to do an enzyme catalyzed reaction for a compound.
No, ma'am, if we are doing like something, we want to check application of our synthesized compound on an enzyme, then how to choose that enzyme?
Okay, for you want to have let me clarify the question. You have synthesized a compound. Okay.
Yes, ma'am.
Now you want to see that whether this compound is having any application toward medicines.
Yes, ma'am.
So then you will have to select that enzyme on the basis of the involvement of enzyme, that which enzyme is involved in that particular disease. For example, if you want to work on anti-diabetic,
Okay, ma'am.
you will have to see those enzymes who will be responsible for the glucose metabolism. Then you will have to target that particular enzyme. Usually what we do, suppose starch is being converted into, you have any idea of enzymes?
No, ma'am.
Okay.
I am a non-medical student.
Okay, you are a non-medical student. Enzyme, in case of diabetes, very simple enzyme what we target is, it is amylase enzyme.
Okay,
Because starch will be first converted into glucose monomeric unit or dimeric units by the help of enzymes amylase. And then if we want to have an anti-diabetic agent, it is one part that all amylase inhibitors will not be anti-diabetic, but we can at least report them that they are probable anti-diabetic agent. If we are able to develop an inhibitor for amylase, then we can propose that this can be an anti-diabetic agent. Like I said, in case of inflammation, there is an enzyme called COX enzyme, COX-1 and COX-2, cyclooxygenase enzyme. For anti-inflammatory agent, you can target COX enzyme. For that, you will have.
Ma'am, how we find out that a compound is active towards that particular disease?
Okay. In that case, you have to perform different experiments. One in presence of the compound, one in absence of the compound.
Without an experiment, we cannot
No.
predict any.
If you want to do in vivo study, then you have to perform experiments wet in the lab, or computationally you can determine the interaction between the ligand and the enzyme, where I told earlier that this computational studies can be helpful for determining, for at least giving you a brief idea that it will be interacting and can be a good inhibitor for the compound.
Okay, ma'am. Thank you.
Thank you, Dr. Neera. You have really delivered a nice lecture and made up on the time that we were running a little short. Thank you very much. The organizers, if wish to say anything, otherwise I'll take from here, because I have another meeting at 12:15, which I'm supposed to attend urgently, so I'll directly shoot to my part of the story.
Well, thank you, sir. Thank you so much for your presence. And thanks, Professor Neera, for your keynote presentation. Thanks, Dr. Sudhir Kumar, for chairing the session. And with this, the keynote presentation session is over. We are already running some minutes behind the schedule, so I won't take much time. And I would like just announce the session to be over, and we'll meet after 15 minutes after a break. Is that all right? Anything to add, convener, sir?
Dr. Deepa, say it again. We'll be meeting after 15 minutes.
Yes, sir. We'll be meeting after 15 minutes, sir.
Listen, I was supposed to talk at 11:30 to 12:30.
Yeah, exactly, because we are running slightly behind the schedule. If you want to start in continuation...
yeah, I'll finish within 30 minutes.
All right. We can carry over, sir.
I hope no one has any objection. Any objections,
No,
anyone?
ma'am. No, ma'am.
Okay. Okay, sir. Sir.
सबका कंटिन्यू करवा दीजिए मैम.
Okay, okay. We have Dr. Rashmi with us. She'll be chairing this session. We are starting the next technical session now. I welcome you, Dr. Rashmi. Dr. Rashmi is the Associate Professor in the Department of Chemistry, Indira Gandhi University, Mirpur. Dr. Rashmi, I would like to introduce to you that she did her PhD in 2004, and she has many awards and recognitions to her credit. She has received the University Research Fellowship awarded by Kurukshetra University. She has received the Junior Research Fellowship in Defense Research and Development Organization, Ministry of Defense, Government of India. And she has qualified National Eligibility Test, of course. And she has been Summer Faculty Research Fellow in the laboratory of Shivaji Rao Gola, Department of Chemistry, IIT Delhi. She has teaching experience since February 21 till continuing. In IG University, she has been Associate Professor on Deputation in IG University, Mirpur earlier to this, and she has been Assistant Professor in Kurukshetra University, Kurukshetra from August 2004 to November 2020. So, a vast experience and very learned professor of chemistry, Dr. Rashmi Pundir. I would like to invite you to chair the session, please.
Thank you, ma'am. Thanks for reading my CV. Am I audible?
Yes, ma'am, you're perfectly audible, please.
So, at the outset, I would like to welcome the speaker of the session, Professor Sudhir Kumar, who is from the Department of Molecular Biology, Biotechnology and Bioinformatics. So, Professor Sudhir Kumar is having very vast experience of research and teaching, of course. He has done his PhD from Kurukshetra University under Professor Pujari in 1990.
Dr. Rashmi.
Hello, sir. I will read in short. I know you are.
Good morning. These things have already been said and these are insignificant. So let's come to the story first.
Oh, okay, sir. I would like to welcome our eminent speaker, Professor Sudhir Kumar, in the first technical session on the topic, the chemistry, our life, our future. So, Professor Sudhir Kumar, please, you may start with the topic.
Thank you, Dr. Rashmi. Let me start the presentation. Good morning, everybody. As I have been introduced as I am associated with the Department of Molecular Biology, Biotechnology and Bioinformatics. The reality is that I am a chemist by training. I did my PhD and earlier teaching, etc. in the discipline of chemistry only. I'm sorry, it is a little bit. Let me bring the slides. Just bear 1 minute with me. So I'm going to talk about chemistry, our life, our future. I'm not going to talk about traditional chemistry that we do or the lab chemistry that we carry out or the applications of chemistry. Rather, I would like to have a look on what chemistry is, how it has affected or is affecting our life and how it will do it in future. Most of the chemists are aware that the International Year of Chemistry was celebrated in 2001. Which was a recommendation from IUPAC, which was accepted by UNESCO, and 2011 was commemorated or endorsed to be the International Year of Chemistry, which itself entails the significance that discipline of chemistry bears on the journal. The objective for having the International Year of Chemistry was to raise the awareness of chemistry among journalists, to increase public appreciation of chemistry as a means to meeting world needs, both in terms of health as well as food. Third was to attract young people to chemistry as science and as career. Because most of the people during this era or even today also, they prefer to go to technology sciences, and the basic sciences, particular chemistry, is the third or fourth choice. So the emphasis was to make it as a career for the young students and to highlight the role of chemistry in solving national and global problems and to generate enthusiasm for creation of chemistry. Now, chemistry, as I call it, it is often called the central science because of its role in connecting the physical sciences with the life sciences and applied sciences. If we try to see the evolution of sciences from rationalization and logic to the evolvement of law and ethics, the rationalization went to mathematics, which in turn gave birth to the science of physics. And from physics came chemistry. This chemistry has in turn given rise to the modern sciences, which are xenosciences or biology or nanosciences, and then the different sciences which emerged from this, like computer technology, engineering, agricultural sciences, medical sciences, etc. So chemistry is in the center of evolution of all sciences, may it be career, may it be development, may it be health, may it be food. So what we'll be talking about during this time is the history of chemistry, branches of chemistry, chemistry in our life, future of chemistry, and chemistry in future life. If you take a little travel in history, go back to the times, I have tabulated it, taking from various sources, that how chemistry has evolved in history. From black magic era or prehistoric time to alchemy to traditional chemistry to modern chemistry, and in turn leading to the future chemistry. The earliest mention that comes is in 1700 BC, where the metals were listed in conjunction with the heavenly bodies. For example, gold was related to sun and the day was given Sunday, silver was to moon and Monday, iron to Mars, Tuesday, and so on and so forth. In 430 BC, Democritus of ancient Greek, he proclaimed that atom is the simplest unit of matter. All matter was composed of atoms. In 300 BC, Aristotle gave another concept. He said that there are only 4 elements, fire, air, water, and earth. And all matter is made up of these 4 elements. And these elements have 4 properties: hot or cold, dry, and wet. No other properties, no other elements. That was the proposal of Aristotle of ancient Greek time. But from 300 BC to 300 AD, the alchemists appear. It was influenced by Aristotle's idea. Alchemists attempted to transmute cheap metals to gold using philosopher's stone, which in our mythology is called the Paras Patthar. Never happened. From 13th century, that is 1200s to 15th century, the failure of gold business. Although it was dictated that gold can be prepared from cheap metals, but the Christian popes, they declared that making gold is not possible, so it should be left with. In 1520, another concept came that chemists were trying to make elixir of life, which we call as Amrit. Chemists wanted to find a chemical concoction that would enable people to live longer. Amar hone ke liye jo kuch peene ke liye milta tha, so chemistry was trying to evolve that. This also never happened. And in the end of 17th century, this total chemistry ended, and Robert Boyle gave the Boyle's law, from where the modern chemistry started appearing. In 1700, another theory was given, that is called Floggistan Theory, which said that when a substance is burnt, phlogistons were supposedly added from air to flame the burning object. मतलब जब भी कभी आग जलती है तो phlogiston air में से आकर के आग को जलाते हैं. But Charles Coulomb gave another law, and this theory was later on disapproved. Phlogiston theory was disapproved by Lavoisier, who who we all know that he gave the concept or he invented oxygen. It is the oxygen, not the phlogiston, which burns the fire. Then in 1800, Dalton gave the atomic theory. Then there were several other inventions, 1854 vacuum tube, then 1896 pitch blende. In 40s, Manhattan Project was there. We know Manhattan Project with the nuclear energy or nuclear bombs. It is associated. So this is how chemistry evolved. And after 40s, chemistry gave so many branches, so many disciplines emerged from this basic chemistry. I have listed a few branches. You can name even a few more than this. One such branch which emerged from chemistry is called bioinformatics. Since I'm doing bioinformatics since last 15-20 years, so I'll be talking 2-3 slides about bioinformatics. Bioinformatics is conceptualizing biology in terms of macromolecules. See, the definition itself brings the chemistry here. It is conceptualizing biology in terms of macromolecules. If we assume that biology is nothing but macromolecules, and then we apply the informatic techniques to understand and organize the information associated with these molecules on a large scale, it becomes bioinformatics. Another definition, of course, people give is that mathematical, statistical, and computing method that aim to solve biological problems is also called bioinformatics. Now, the two uses of bioinformatics, of course, like we have seen in this Corona times or COVID times, the vaccines have appeared so quickly. Earlier, the vaccine, I don't know whether this slide is visible to you or not. I'll share it with the organizers and you can have a look at, or you can Google it, the reverse biology analogy. You will see a diagram whereby the half part of it is the traditional development of vaccine, which takes anything like 5 to 15 years. And the lower part, that is this part, it deals with the usage of computer and bioinformatic tools, whereby a vaccine can be prepared or developed if you are lucky. Mind it, computer is not the key that it will give you the 100% result. If you are lucky, you can have a vaccine in 1 to 2 years. That is why I have termed it as reverse biology. Biology which starts from the result and then goes to the question. Similarly, bioinformatics can be used to find drug targets, not drugs. Be very clear. Bioinformatics can be used to find drug targets, and then these targets need to be validated in the laboratory and then in the clinical trials. Then this becomes the drug. These are the steps listed here, how the drugs are developed making use of bioinformatic tools. I'm not going to details of it. If anybody is interested, he or she can read it separately. But what I want to emphasize here is that during the development of drug, making use of bioinformatics, chemistry plays a pivotal role. Of course, small molecules are chemicals, so chemistry is there. Even large molecules, they are also chemicals. We call them macromolecules. The bioinformatics find in application in so many areas, may it be medicines, may it be therapy, drug development, or even crop improvement, insect resistance, nutritional quality enhancement, and so on and so forth. There is another area which has come from chemistry. Of course, it is chemistry, but when we apply the informatic techniques to it, it becomes Chemo Informatics. Some people call it Chem Informatics, some call it Chemo Informatics. This term was coined in 1998, and it is the use of computer and informational techniques applied to a range of problems in the broader area of chemistry. The Chemo Informatics makes use of file formats. Those of you, most of you are from the new generation, they are aware of about the usage of computers in day-to-day life, and they know कि वर्ड की फाइल है, ये एक्सेल की फाइल है, ये पावरपॉइंट की पीपीटी है. Similarly, for chemistry also we have file formats, and one very simple, commonly used, oldest format is SMILES, S-M-I-L-E-S, which is XML-based chemical markup language. For example, if we write ethanol, a chemist will write it C2H6O, or you can write it C2H5OH, but the SMILE for this will be CCO. Similarly, for benzene, the SMILE is different. All 6 carbons need to be named. Then 1-1 means they are joined at one position. You can study SMILES, but chemistry in computer, Chemo Informatics has different file formats. I have listed So many file formats. If anybody is interested, he or she can go through. Somebody was asking that if we want to, in the previous lecture of Dr. Neera, that how do we know that which chemical is tested or can be potentially active against which enzyme? For that, we do virtual high throughput screening, which also sometimes people call it docking. It is of two types. One is called the ligand-based virtual screening, other is called the receptor-based virtual screening. Once you have a ligand and you have identified that this ligand potentially can be active against this particular enzyme, then you do the ligand-based screening. But if you have a single ligand, single protein, it is called simply docking. If you have a large library of small molecules, say 10,000, 100,000, or maybe even 1 million compounds, and you want to screen all those compounds for their efficacy against a particular enzyme, then you carry out the virtual high throughput screening. So that's also a chemistry in silico. Similarly, the quantitative structure activity relationship, whereby we study the effect of various substituents or pharmacophores on the activity of the compounds. Of course, we do it in lab and then statistically evaluate the QSAR, but the same activity or same property of QSAR can be studied in silico as well in computer. If we have two groups of informations, one is called the test set, other is called the training set. If we have prior information about the activity and structure of one group of compounds, which are directly related to the test group of compounds, then we train our program with the test set, training set, and then apply it to the test set and get the results. That is called the in silico quantitative structure activity relationship. Similarly, additionally for chemistry, we have chemical databases. Chemical databases are small molecule databases whereby you get the structural information about all synthesized compounds. Of course, there are some methods of submitting the compounds to these databases, and these databases curate the database at their own. They curate the information that is there. Two such small molecule databases are Cambridge Crystallographic Database and the Zinc database. Then there is another concept while using the Chemo Informatics, combinatorial chemistry. I'll make it very simple. I'll tell you in straight. Hello. Somebody is saying something? No.
Kindly continue, sir.
Okay. Combinatorial chemistry it applies to creation of combinatorial libraries. Suppose I have a molecule which shows X activity, and I want to try that if I change the substituents in this compound at position A, B, C, X, Y, Z, and then what would be the activity of the compound. To do so in laboratory, I'll have to synthesize all possible combinations thereof. But computationally, we can create a combinatorial library. And if a compound has three substituents, R1, R2, R3, we can generate NR1 into NR2 into NR3 possible structure, where N is the number of different substituent. R1, how many R1? How many R2? So we can create a database of compounds which are theoretically generated, and that is called the combinatorial library. And the application of combinatorial library for screening is called combinatorial chemistry. This is an example how to create it. I'm not going in details of this. The computational chemistry makes use of certain theories or certain methods which are listed here, like ab initio calculation, semi-empirical calculation, modeling and solid state, molecular mechanics, molecular dynamics, and so on and so forth. Now, chemistry in life, I'll touch just two things. Chemistry in life, that is molecular biology. Now we have another new discipline which is called molecular biology, and chemistry in everyday life. I always proclaim that anything and everything you see around you is chemistry, directly or indirectly, including water. There is a small cartoon here. If you can see it, enjoy this cartoon. Now, nature to chemistry, how we came from nature to chemistry. One example is the discovery of penicillin in 1929, which was a medicine which could destroy bacteria, was extracted by him from a mold. So nature gave us the lead to develop, and once penicillin was invented, synthetic penicillins also came into being. Chemistry also comes in food in different forms, may it be carbohydrates, lipids, proteins, vitamins, additives, food fortification, food preservation, food supplements, nutraceutical, nutrification, and so on. Even food packaging, there also chemistry is there. The food that we eat, the food that we pack into. And the broader area is called food chemistry. Similarly, polymers, they are also nothing but chemicals, a result of chemistry. Vulcanized rubber, bakelite, neoprene, nylon, polyvinyl, butyl, and so on and so forth. Glass is another simple example of chemistry, which was first prepared in 3500 BC from sand, lime, and soda ash. So, the cement is another which has changed the modern world. Of course, it was called the porcelain cement, but it is a definite fixed chemistry, Portland cement. Fermentation is another chemical reaction or chemistry, which is probably the oldest chemical reaction known. Earlier, it was used to ferment the carbohydrates to prepare alcohol, and now the fermentation, and later on fermentation was used to prepare the bread or other kind of stuff. Chemotherapy is another area where chemistry finds application. Everybody is aware that this is a method of fighting cancer. Chemistry is present in dyes, cosmetics, perfumes, ceramics, soaps, and detergent. You name, and it is everywhere. Acid rain is chemistry, air pollution caused by chemistry, steroids, asbestos. This is the little negative aspect of chemistry, which has, of course, influenced our lives, but it has created the side effects also. Chemistry has so many elements. Chemistry has a central role in science, and synthesis has a central role in chemistry. So the typical synthetic part of the chemistry will never go in vain. Human Genome Project is one example where I definitely put chemistry in the center of it. Human Genome Project, most of the chemists generally are not aware, but now your generation knows that Human Genome Project, the first draft was published in 2002 or 2003, and now the gaps have been filled and the final draft is available. It is nothing but the information of ATGC, the total genomic content, and this will lead to our different approach to medicine and health. Solar energies, Dr. Neera was mentioning it, then chemistry goes green, of course, green chemistry, Dr. Neera has already touched it, prevents waste, it designs products like this. I'll just take a minute for the promises that chemistry gives is in pharmacogenomics. Pharmacogenomics is one area which is slowly emerging after the completion of Human Genome Project. It promises to give tailor-made medicines. Like we get our clothes stitched to our fitting. Similarly, in times to come, maybe in your generation or next generations, everybody will get the medicines which are tailor-made to their specific disease and their specific genome. The total genome content would be stored in some kind of device, maybe a card or a pen drive or something, and then the scientist will analyze that which part of the genome is misbehaving or where the disease causative gene is, and will design, synthesize a medicine specifically for that particular gene, which translates into the causative protein of the disease. And that area is called pharmacogenomics. I call it tailor-made medicines, which is a promise for future, and we are sure in coming times it will come to us. Thank you very much. Any questions? I can hurriedly take it up. I'm sorry I'm running late for some other engagement for some reason which I was not aware earlier when I said yes to the organizers. But I hope you can understand and excuse me for that.
Okay, thank you, sir. Thank you very much. Any question from the audience?
I'll share these slides. If anybody is interested, he or she can go through, just read. This is not my material. I have collected it from different sources.
But one thing I would like to add, sir, your source of motivation for all of us, from being a synthetic organic chemist to start the bioinformatics in your department. So it is really appreciable. And your talk, you are right in saying that adding bioinformatics like computational tools, they have reduced the time and efforts and chemicals for drug synthesis. It was very
Yes, Dr. Rashmi, I would like to add here one thing. All chemists, please don't mind my straight words. All chemists always talk that drug design. It is not that simple and straight area. See, because drug design is very frustrating area since very beginning. If you are aware, as of today, we have something like 6,500 molecules which are drug-like, and only 3,200 molecules are drugs which are marketed. So this area is not really that simple. So all chemists should abstain from this. That drug design I want to join.
Sir, may we have one question? Dr. Deepa Sharma has raised the hand. Dr. Deepa, would you like to ask the question?
ठीक है, क्या है? तो बराबर आना चाहिए तो ऊंचा नीचे.
Miss Richa, please mute yourself. Richa is requested to mute. Yeah. Dr. Deepa, would you like to ask the question? You're not audible, ma'am.
Dr. Sudhir, thanks for the informative talk. And I would not take much time. Just if you can mention some of the softwares you have been using.
The software are of two types. One are called the structural software, other are called the analytical softwares.
Yes.
So which type of software you exactly need? There is a long list of it. For example, for a chemist, a 2D drawing software, you can use any kind of ACD, ChemSketch or something. As far as the drug design docking thing is concerned, there are so many softwares, but I personally use DOCK, D-O-C-K. And
D-O-C-K, sir?
Yeah, D-O-C-K. It is, it's available in both standalone as well as parallelized version. Because once you are screening a large library, then the simple computer on your desktops are not sufficient for that. So you need to have parallel computers, and DOCK is good one for that. But for chemists who are doing the focused docking, AutoDock is one software.
AutoDock, sir?
AutoDock is one software,
which
I have found very good and simple to learn.
Are these open source, sir?
Yes, both are open source. DOCK is paid, but for academicians it is free. You need to sign a license for that. AutoDock is altogether open source and you can get it.
All right.
AutoDock is fancy window kind of. DOCK is command line based Unix software.
Okay. So there are any graphical interfaces, or you use commands?
AutoDock has total graphical interface. DOCK has no graphical interface. You get the results from DOCK and then you visualize it in some visualizing software like Swiss PDB or even Vienna or Chimera, that kind of software.
Okay, thank you, sir.
Yeah.
So there is one more question from Miss Mehak Dalal. Yes, Mehak, please ask your question. And one more is in the text box. How to identify, it's from GP Shija. How to identify PDB IDs for unknown compounds or synthesis compounds?
Actually, PDB ID is nothing but an ID given to a structure of protein solved experimentally. So, if you search the PDB site, that is rcsb.org, if you know the PDB ID, you will get the structure. If not, then you give the name of the enzyme whose structure you are looking for. It will give you the PDB ID. rcsb.org. Does that answer the question?
I think so,
Okay.
because she's not talking. So
Okay.
thank you, sir. There is no other question in the chat box.
Okay, okay, appreciate.
Thank you, sir. Thank you very much for the talk and your time.
Thank you, ma'am. Thank you.
Okay,
Thank you, everybody. Thank you. Appreciate. Thank you very much.
Well, thank you, sir. Thanks for your precious time. And thank you, Rashmi ma'am, for chairing over the talk. And
Thanks, organizers, for inviting me to chair the session. Thanks.
And carrying forward without delaying any much, because we're already running behind the schedule, I would like to invite Dr. Raj Kamal from Kurukshetra University, Kurukshetra, to chair over the next talk, please. And Dr. Raj Kamal, I would like to introduce you that he is from Kurukshetra University, Kurukshetra, Department of Chemistry. He is the life member of Association of Chemistry Teachers, life member of Indian Chemical Society, life member of Indian Science Congress Association, life member of Vigyan Bharati, and he has been member of various committees in the Kurukshetra University, like he was elected member Executive Council of Kurukshetra University, he was elected member University Court of Kurukshetra University, he was member of PGBOS in chemistry, he is subject expert in Haryana State Education Board Bhiwani and Indira Gandhi National Open University, New Delhi. So I will request Dr. Raj Kamal to take over, please. Dr. Raj Kamal. Is Dr. Raj Kamal there? हेलो हाँ जी सर कर दिया सर अच्छा ओके So there's slight change in the program as this session was started without a break. So the break will take now. There will be a 15 minutes break now, and the next speaker, the session will continue after this break only. So a break for 15 minutes, please. Welcome, Dr. Ramesh sir. Dr. Ramesh Kataria sir, you are welcome in the session.
Thank you, madam. Thank you.
Dr. Raj Kamal is there. Gulab sir, are you there? We'll be
Yes.
starting the session in a minute or two.
He is joining, ma'am.
Okay, sir.
He is trying to join.
Okay. Ramesh sir, if you have joined just now, I would like to inform you that this is a 2-day international conference on new trends in chemical research. The inaugural session was completed in the morning itself, and the technical session, the first speaker has delivered his address, and you are in line after him after this break. So since it was a break, participants may take few minutes to join, so kindly bear with us.
Sure, madam. Sure.
And we are running 10 minutes behind the schedule, sir. So I'd request you to kindly keep that in mind.
Sure, madam.
Okay.
I will try to be that finish as per your instructions only.
Yeah. Means your scheduled time was 12:15 to 1:15.
Yeah.
And it's we are running 10 minutes late. So you just cover up that, right?
Madam, sometime that while talking, I forget that how much time is remaining. Just give me just some signal.
Yeah, no problem, sir. गुलाब सर, आप प्लीज चेयरपर्सन से कांटेक्ट कर लीजिए.
Deepa ma'am.
हाँ जी.
Rajkamal sir has joined.
Okay.
Rajkamal sir is on this.
All right, all right. Welcome, Rajkamal sir.
Thank you, Dr. Deepa.
Yeah, you have been introduced in your absence already. So audience are well aware of your achievements, and I welcome you to kindly chair the session. I won't take much time because we are running behind the schedule, so you may kindly take over, please.
Okay. Thank you, Dr. Deepa. It's no problem.
Yeah.
Okay. Now, on behalf of organizing committee of this international conference, I would like to welcome Dr. Ramesh Kataria, the speaker of this present technical session after the tea break. And Dr. Ramesh Kataria is my classmate. Yes, it is a matter of pride. It is a matter of very pride for me to introduce one of my classmates, Dr. Ramesh Kataria, among the audience of this international conference. As Dr. Ramesh Kataria joined the Department of Chemistry, Punjab University, Chandigarh, as assistant professor on 2013, and prior his joining in the Punjab University, he served as assistant professor in Bhaskaracharya College of Applied Sciences, University of Delhi. He did his PhD, MSc even. He did his MSc and PhD from the Department of Chemistry, Kurukshetra, University Kurukshetra. And he has total 13 years of teaching experience and research experience, 18 years. Total, he has 65 research publication in his credit of the journal of very national and international repute. He guided independently 3 PhD students, and presently more than 6 PhD students are still working with under the supervision of Dr. Ramesh Kataria. He has vast experience of his research, including the postdoctoral research experience from the University of Alabama, USA, and at the same time from the Korean Atomic Energy Research Institute from South Korea. He authored and co-authored several national and international publications, and moreover, he is the recipient of so many awards, particularly the Raman Fellowship from the UGC. Now, with these words and without wasting so much time, I would hand over the mic to Dr. Ramesh Kataria for his talk. Thank you.
Thank you, Dr. Rajkamal, for your nice and you can say that very long introductions. Thank you very much for your kind words. And I would like thanks to Dr. Deepa Sharma also for giving me a nice overview of this today international conference. First of all, let me just share my slide first. I hope that my slide is visible to you all.
Visible, sir, visible.
Yeah, thank you very much. Okay, first of all, that I would like to thank Dr. Gulab also giving me opportunity to interact with the young minds. And I would also like thanks to that Shahid Bhagat Singh, Udham Singh, Government College, Matak Majari, Indri, Karnal, for organizing a international conference. Though I can understand that to organize a small event is not an easy task, even that this Shahid Udham Singh College is organizing international conference. So I must say congratulate all the organizing teams and specifically that convener and co-convener of this international conference. As Dr. Rajkamal is mentioned about in my introductions that I did my educations from Kurukshetra University, Kurukshetra, and after that I served for a couple of years in Delhi University. Then I joined Punjab University in 2013 only. As he mentioned, he is my good friends and he is my classmate also. Likely the same way that Dr. Gulab is also my you can say that junior. I did my master in 2003 and he did his master in 2004 only. Again, that I would like to thank to Dr. Rajkamal for inviting and giving me opportunity to interact with young minds.
As per my topic or as per my interest, today I will interact on the recent development of materials for the reductions of the heavy metal ions. Dr. Rajkumar, excuse me for that, because you might heard about this lecture earlier also. Because due to my busy schedule, I am not able to just maybe change so many things.
Okay. No problem at all, Dr. Ramesh Kataria. Please continue.
Yeah. As per my topic, that I have to be interact mainly on these three issues. Why we need heavy metals? What is heavy metals? Why development of the new material is required for the sensing or detections of the heavy metal ions? If time permit, then little bit I will explain few of my research papers. As I mentioned that why heavy metals? In these slides, I have tried to be explain what is the exactly source of heavy metal ions. Whenever we are discharging our day-to-day duties, we are interacting with so many heavy metal ions. For example, you might heard about these fossil fuel combustions, mining, smelting, waste disposable, corrosions, or even some metallurgical process which are happening in day-to-day lives. Directly or indirectly, all these procedures or all these phenomena are responsible for the contaminations of the heavy metals into the environments or our food chain. Now I will give you that very simple example of the mercury. As you can see, based on our residential area, or you can say that based on our residence, as you can see that we are living in this North India, and we are eating every day that rice or wheat every day. If the people who are residing near to the coastal areas, generally they are dependent on the seafood only. As we are eating rice and wheat, or you can say that chapati, the people are eating fish in their routines, or maybe in day 2-3 times. In this way, any contaminations in the seafood later or sooner may enter into our food chain. Then immediately question arises, how, sir? As you can see that whenever, if any contamination in the seawater, as I mentioned that I have taken the example of mercury, if any form of the mercury consumed by the fish, and the same fish may be eaten by some persons who are residing in these coastal areas, maybe get contaminated with methyl mercury, or even generally that in the last 2-3 years, we are facing a lot of problems towards Corona-19. Due to Corona, I'm sure that in every home now having thermometer. Even during Corona second wave, every person is using thermometer maybe 20 times in a day to check the temperature. If any breakdown will be takes place with thermometers due to mishandling, again, that may connect as the source of the heavy metal ions like mercury into the atmospheres or in the environments. Third example, I have taken the sun cream. Now you can say that in today's or nowadays that temperature is around 40 or 45. That every person's or most of the people's, you can say, applying sun creams. Or sometime for the safer side or to save money, the people are just buying the cream without knowing the compositions of this cream. Sometimes this cream itself having some heavy metal concentrations. We are just for the smartness, for the beautifications, Yes, please. Am I audible?
Hello.
Yes. Hello. Dr. Rajkamal.
Please continue, sir.
Hello,
Am I audible?
kindly switch off mics,
Hello.
everyone except the speaker.
Hello, Dr. Deepa.
Yes, sir.
You please mute Mr. Ravit Malik. There is some problem in the mic from side of Ravit Malik.
Our technical team, please take care of.
We have muted,
Yeah.
sir.
Okay, hope I am
Okay,
audible.
thank you. Yeah, please continue, Dr. Ramesh.
Yeah, thank you, Dr. Rajkamal. As I mentioned about this use of the creams or contaminations of the heavy metal ions. Similarly, that you might heard about the acrodynamia, or you can say that mercury poisoning, or you might also heard about the Minamata disease, which are responsible due to the poisoning or contaminations of the mercury to the food chains. Around in 1956, in Kumamoto and Niigata prefectures in Japan, as I mentioned, if you are living around the coastal area, you are dependent upon the seafood. The people are eating fish on their routine basis to fulfill their food desires. Anyhow, due to some factories located at these regions, which are giving some waste products as an methyl mercury. At that time, that this company or even that Japan government, you can say that everyone is interested towards for the manufacturing rather than the environmental problems. As I mentioned about the acrodynamia mercury, that is very much common in these childs. Or similarly, that if you are talking about this Minamata disease, that Minamata disease is like a cerebral palsy. That in the slide that I will try to be explain how the contaminations of the mercury will be enter into the food chain. As you can see that in this factory, they are using acetylene and trying to produce acetaldehyde first by using mercury as an catalyzers. You can say that simply inorganic mercury, you can say HgCl2 as an catalyst. With the formations of the acetaldehydes, there is some byproduct methyl mercury. And this company is not worried about these byproducts, and they are just throwing their waste into the local sea. Now we can say that this methyl mercury enter into the sea. And this methyl mercury located in the seawater, there maybe some biological functions or biological reactions may be taking place, and the same intakes taken care by the fish. And this fish, as I mentioned, that in coastal area, generally we are dependent upon the seafood. These fish are used as a food for the people who are residing around the coastal areas. Now, in this case, you can say that methyl mercury enter into their food chain, or even if, as I mentioned, this disease is very common for the childs. If the pregnant woman is there, they are eating or she is eating that fish, maybe that small amount of the methyl mercury may enter through placenta into the child in the uterus or in the womb, you can say. And accordingly, that they will be reflect some problems of the disease, as I mentioned, acrodynamia, or you can say that Minamata disease. As I discussed about the company is only taking care of the formations of the acetaldehydes by using acetylene, by using that salt of the mercury. You can say that inorganic mercury. And further, as I mentioned, that methyl mercury will be side product, and then acetaldehydes further by oxidation can change into acetic acid or other derivatives as per the requirements of the society. Similarly, that I would like to mention the another examples. As I mentioned, that contaminations of the methyl mercury. You might heard about this amino acid, that is cysteines. Whenever that cysteine come in contact with methyl mercury, then the formations of the cysteine methyl mercury takes place that will be analogous to the methionine. Sometime in our body, that system is not able to recognize whether it is a methionine or whether it is a cysteine methyl mercury, as it will be worked as an analogous of methionine. In this way, that mercury will be entered into our food chain or in our metabolism, you can say. Okay, now I will try to be that second part about the development of the materials. Whenever we are talking about the development of the materials, we are trying to be developed as some sensitive methods which can be depend upon the very easily or low cost effective or low time consuming, or sometimes that we are prefer for the development of the systems or methods that can be used directly at the field area. Even you can say, if we are talking about their reductions of the heavy metals, in nature we are having number of instruments that can be used for the reductions of the heavy metal ions. Like AAS we are having, atomic absorption spectrophotometry. ICP-MS we are having, inductive coupled plasma mass spectrophotometry, or in this way we are having number of methods, but all are very costly or instrument dependent. That's why we need a particular system or methods that can be cheaper or that can be directly applied at the field. Because sometimes that while taking some samples field to laboratory, there may be some reactions taking place and change the nature of the heavy metal ions. Here that I would like also give the one example of the cancer train. You might heard about the cancer, particularly of the Punjab, Malwa belt, you can say. One train started from Batinda to Bikaner every day. The people are saying cancer train. That immediately question arises, why the people say cancer train? What is the reason behind this? Because in this train, the people are sitting inside the train, they are looking for treatment for cancers in the Bikaner hospitals. In every day, minimum in this train, around 100 people are visiting to Bikaner from, you can say that, Batinda. Or till date that we are not able to find out the exactly cause of cancer in the Malwa belt of the Punjab. Now recently that government given the so many ROs to keep in considerations, this cancer is due to maybe contamination in water. Or some of the research articles claiming this cancer is irresponsible or cancer is due to the high use of insecticide or pesticides. Or similarly, some of the research paper also claiming it may be due to heavy metal ion or radioactive elements also. That's why we are discussing today here the reductions of the heavy metal ions. As I mentioned that we need some specific material that can be used for the reductions of the heavy metal ion easily or directly at the field. So generally we are prefer while developing some materials using gold nanoparticles. Then immediately question arises why we are preferring to gold nanoparticles. Because that gold nanoparticles are easily to synthesize in the laboratory, or even that toxicity level is very less in case of gold nanoparticles. As per our desire, we can be easily used for some biological system also. Or even that these nanoparticles having unique optical and electrochemical properties that directly can be explained in terms of their size, shape, or aggregations of the particles. For example, as per our requirements or as per our desires. I will give you another example. When I was in USA as a postdoc fellow, I was in Tuscaloosa in USA. Then I heard about the Alabama, there is some tendency for the contaminations of the waters, particularly for heavy metal ion in that area where I am used to or to just to complete my postdoc fellow. Then I went to Walmart and I asked, sir, just give me one filter so that I can drink safe water. Then immediately that person asked, sir, please tell me in which area you are residing. Then I said, what is the, why you are asking my residential proof or why you need my resident locations? Is there any reason, specific reason? He mentioned, sir, we have some reports as per their particular area. If you just explain the particular area, then accordingly we give you that RO or filter types. Then I was surprised to see the understanding of the vendors regarding or towards the environments, you can say. In this way, as I mentioned about the example of the heavy metals types, accordingly by using gold nanoparticles, we can develop the specific sensors or materials that can be used for specific sensing of the particular heavy metal ions. For example, suppose whenever we are having gold nanoparticles, we have to stabilize the gold nanoparticle by using sub-stabilizing agents. Like as per our desired, suppose we are having this stabilizing agent or that can be used as an recognizing elements. As you can see this one, by using this one, we can specify for towards particular heavy metal ions, or you can say that analytes. In this way, you can see that these analytes may be fixed or may be having some high interactions toward these particular sites, and immediately there may be some signal appears. And this signal appears may be used as a particular sensing for a particular metal ions. Similarly, whenever we are doing that some work based on the gold nanoparticles, in literature you can see we are having functionalization nanoparticles as per our desired or as per our requirements. Whenever we are explaining the mechanism of the reactions, then you can see in literature we are having the reductions of the heavy metal ion through aggregations or disaggregations only. What is the meaning of aggregations or disaggregations? Now you can see, as I mentioned about the gold nanoparticles stabilized by some functionalization ligands. Due to these interactions or due to the presence of this ion, there may be some attractions will take place which leads to the aggregations of the gold nanoparticles. And due to the formations of these aggregations, there may be change in their you can say that surface plasmonic resonance. That immediately we observe some changes in their UV and fluorescence, and accordingly we can detect. Or similarly, second, we are having some aggregations among the gold nanoparticles. While putting specific element, there may be some disaggregations will take place. In this way, we can detect the amount of the heavy metal ion into the solutions. For example, suppose if we are having citrate stabilized gold nanoparticles, whenever we are putting mercury ions, then you can see that layer of the mercury will takes place over the surface of the gold nanoparticles. Or you can say that mercury coated gold nanoparticles. If we are adding lysine, as you can see that we are having NH2 or we are having OH, then it may be interact towards mercury and as well as gold nanoparticles. Due to these interactions toward both the sides, that lead to the formations of the some aggregations of the gold nanoparticles. And these aggregations of the gold nanoparticles lead to the change in their specific surface plasmonic resonance. As you can see that colorimetric reductions of the mercury using lysine. As you can see, whenever we are having gold nanoparticles that are red in color, whenever we are putting lysine alone, then there is no aggregations, that gold nanoparticles will be existing in dispersed phase only. While putting mercury alone, then again it will be existing as it is. But if after putting mercury, if we are putting lysine, then it will be changed into blue in color. Even by putting that lysine, that aggregations will be takes place. Then immediately we can say that the colorimetry sensors will be appears, or we can be deduct the concentrations or presence of the mercury ion among the water samples. That's why there is no need of instrument like AAS or ICP-MS. By doing this one, we can immediately say that mercury is there. So in this way, that we are trying to be developed the materials that can be directly used at the workplace or at the field, you can say. Similarly, that we have another example of the, you can say that guanidine thiocyanate. Accordingly, it will be happen in the same way as it happened in case of the last cysteine-based gold nanoparticle aggregations. But in this case, it will be depend upon the guanidine thiocyanates. As you can see that whenever we are having stabilized nanoparticles, we are putting cadmium, then there may be some aggregations will take place. And these aggregations is responsible for toward check the concentrations of the cadmium ion, as that cadmium can also act as an heavy metal ions. Similarly, while developing the some methods, we are also preferring the metal organic framework also. Why we prefer to develop the metal organic framework? The development of the metal organic framework will be preferable due to their porous coordinations nature or porous crystalline materials that can having high surface area, or sometimes we can be produced as per our requirements in 2 or 3 dimensional as per the conditions of the reactions. Due to their wide acceptability of this metal organic framework, generally used in sensing, adsorptions, magnetism, storage and separations, optics or catalysis. So that's why we are preferring to develop the more materials in this way. That now I'm just touching my third portions, and then I will happy to be discuss few methods which I have developed at Punjab University Chandigarh for the detections of the heavy metal ions. The first method, I have developed colorimetric detections of the mercury ion based on anti-aggregations of the gold nanoparticle using 3,5-dimethyl 1-thiocarboxymide pyrazole. As you can see, I have mentioned the very simple example. We can synthesize very easily. As I mentioned, I have given the 2 examples, and I have mentioned about the aggregations of the gold nanoparticles. And even you can see in Google that you will get a very few reports based on the anti-aggregations of the gold nanoparticles for the detections of the heavy metal ions. Now I am presenting that this work which I have taken at Punjab University and the University of Alabama, USA. That's I would also thanks to my supervisor, Professor Arunva Gupta, who giving me chance to work on the gold nanoparticles. As you can see that gold nanoparticles are red in color. Whenever you are taking that absorbance of the gold nanoparticles, you will get a sharp peaks at around 520. As I mentioned that I have used a very pyrazoles. After adding pyrazole, immediately that red color change into blue in color. And immediately you can see that peak at 520 little bit will decrease and one new band will appear around 700 degree nanometers. In the third time what I did, I have put the mercury and then I put pyrazole, you can see then after adding the fixed amount of mercury, again there's decrease in this band and appearance of this 520 band will take place. In this way, we quantify the concentrations of the mercury by using colorimetry sensor by using gold nanoparticles. And based on their characterizations, I have taken the TEM, transmission electron microscopic image of the gold nanoparticles. You can see that dispersed gold nanoparticles. While adding pyrazole, you can see that aggregation takes place. And in the presence of mercury, if we are putting pyrazole, there is no difference. It will be act like as in case of A. So that's why we have given the mechanism anti-aggregations of the gold nanoparticles in the presence of mercury. And accordingly that we have to be justify the conditions also, we have to be optimize the conditions that I'm not going on that details. And we have to be, while discussing the methods, we have to be taken care of the interference of the other metal also. And even that this work is further supported by the DFT theory also. As you can see that we have optimized this pyrazole by using that some Gaussians and applying some calculations. And you can see that energy comes out minus 796.51. But in case of this, along with gold nanoparticles, around minus 814.80. But whenever we did simultaneously in the presence of mercury, you can say that this amount is quite less, minus 889.35. This DFT calculations make sure us that the stabilizations of the mercury is much more even in the presence of the gold nanoparticles. And similarly that we have checked the interference, as I said. And as I mentioned that for the quantifications of the mercury ions, we have started with small amount of the mercury and then continuously added the mercury ions. You can see this band going on decreasing order and this bond is going on increasing order. And accordingly that we developed this sensor for the development of the mercury metal ions.
Hello, Ramesh.
Yes, please.
Kindly mute your mics, everyone.
Ramesh.
Our technical
Yes,
team,
please.
please stay on
I
alert.
think your voice is breaking. Hello?
Okay. Yes, I'll take care, Dr. Okay. Now you can see while developing some sensor, I mentioned about that sensor can be used at the field directly. Now you can see that I have taken the water and then I put it gold nanoparticles. As I mentioned, that color of the gold nanoparticle in water will be red in color. If mercury is there in the water, then there is no change in the color. But if mercury is absent, then immediately the color will be changed in blue. So in this field itself, we can check whether this water or quality of the water having some contaminations of the mercury or not. For the sake of justifications, in our laboratory, we have taken the tap water and then we have taken the lake water and then spiked some amount of the mercury, and we have estimated the amount of the concentrations in the samples, and the same samples we have characterized with the help of the ICP-MS, so that we can compare the results of by our methods or with the instrumentations. We have the very good agreement with our results with the ICP-MS instruments results. In this way, as I mentioned about the metal organic framework, we have also developed the one sensors used for the sensing of the zirconium ion using metal organic framework. Or similarly, that we have optimized the conditions for the conditions, and you will be see in this case, generally in nature or in literature, you will see the ton of sensors. and you will get very few reports based on the turn-on sensors. Luckily, that one of my PhD students named Kiran, she developed the turn-on sensors based on the metal organic framework for the sensing of the zirconium ion. And all the estimations of the zirconium having well agreement with XPS, BET, powder XRD, or with the help of some other techniques also. And similarly, as we did in our previous case, we have applied our methods in the water samples, and again we are having good agreement of the results. Similarly, in our laboratory, one of my students named Richa, she developed the directions of the copper ion by using simple benzohydrazide using DHA. In this system also, we recognize the structures of the copper or existence of the interactions of the copper metal ion with ligands in solutions as well as in solid state also. In solid state, we have crystallized the complex and determined the structures, and it is like a square pyramid. In these results, we confirm the bonding or attachments of the coppers with the ligands. Or similarly, as we did in our previous case, we have quantified the concentrations of the copper ion among the water samples. Or similarly, that by using the same one, we have also developed the copper complexes that can be used as a surface disinfectants against the nosocomial infections. We have filed the patent by using these materials, and these materials have very good results for the disinfectant in the hospitals. As I mentioned, that while developing some materials, we have to take care of some techniques also, or with suitable justifications. So I will be happy to say that we have good agreements with the results with our research. Similarly, that
Hello, Dr. Ramesh.
Yes, please.
Hello.
Yes.
Sorry to say, so please bind. You can bind up. Please.
Yes, sure, Dr. Natarajan. Sorry, Dr. Rajkamal, thank you. Similarly, that I have developed another fluorescent sensor that can be helpful for the detections of the iron. As Dr. Rajkamalji mentioned that we are having shortage of time, that I will be just try to wind up with my talk. If anyone having any problems, then I will be share my email ID, or that Dr. Gulab is having my email ID, that can be shared freely with any students. If any problem, then I will be happy to answer to the college students or any audience. In this way, you can say that whenever we are doing some research, we need a sports, sometimes that we need academic sports, or sometimes we need a financial sports. So in this way, that I would like to thanks to our Punjab University for supporting infrastructures to develop some sensitive methods for the directions of the heavy metal ions. And I would like to thanks to university grant commissions for giving me that final support in terms of UG CBSR startup grants or Raman postdoc fellow to work in the USA for 1 year. And we have just finished the one project with the help of the Punjab University Chandigarh, and that as Punjab University supports in the form of financial support as an alumni grant of the Punjab University. And finally, that I would like to thanks to my mentors, Professor A. Gupta, and my supervisor, Harish Kumar Sharma, that who support me during my PhD, and Professor Arunva Gupta support me during my postdoc at University of Alabama. And Junwa Sin, I forget to mention his name. He supported me while working in the Korean Atomic Research Institute at South Korea. Now I have to be, whenever we are presenting our work, we have to be thanks to our collaborator also. As I'm getting a lot of supports from Professor S.K. Mehta, he is always ready to help me whenever I need. Then I would like to thanks to Professor S.K. Mehta also. And similarly, that I would like to thanks my Professor Gigendro, University of Italy. And finally, that this credit goes to that research scholars and master students who are doing that hard work that we are able to presenting in some of the conference. Thank you very much, and thank you very much. Thank you all for listening me.
Thank you, Dr. Ramesh Kataria, for consideration my request.
Yeah.
Now, I would like to say again thanks to Dr. Ramesh Kataria for very informative lecture he given on the topic recent development of material for the detection of heavy metal ions. And during his lecture, he highlighted what is the importance of heavy metals, particularly what is the importance of mercury, what are the positive and the negative effects of the mercury in our life, how the heavy metals entered in our food chain, and how these heavy metals are responsible for various health issues, how mercury, methyl mercury particularly, mimic the cysteine amino acid and enter in the food chain. And due to their contamination of heavy metal or radioactive substance in water, a lot of problem is created in the region of Punjab. Now the session is open for the discussion, open for the question answer. If there is any question from the side of audience, from the side of participant, now I would be very happy. Please, if there is any question, otherwise, as a session chairman, I have to ask something from Dr. Ramesh Kataria.
Yeah, you are welcome, Dr. Rajkamal. You are anytime. Yeah, please.
Yes. Yeah, audience, please. Okay, I think there is no question from the audience side. Now let me ask.
Yeah, Dr. Rajkamal, it makes two sense. Either that the content of my talk is fully understandable, otherwise nothing, zero.
No, it is fully understandable, Dr. Ramesh Kataria, because
Yes.
Let me ask one question from you.
Yeah, sure, please.
Dr. Ramesh, you explained the things very well.
Yeah,
and
thank you.
The detection of heavy metal, the identification of these heavy metals with the colorimetry method.
Yeah.
It is very good. And in somewhere you have discussed some part of the DFT calculations.
Yes.
Can you go to that slide?
Sure, why not? I'm just sharing.
Initially, you have to share your screen.
Sure, yes. Yes, Dr. Rajkamal ji.
Yeah, exactly. This is DFT optimized structure of pyrazole mercury complex and the gold nanoparticle.
Yes.
So I think the interaction of mercury is more exothermic. You want to say this point, no?
Yes. Just okay. Just whenever
what you want
we are
to
just
explain in this slide. Yeah.
Okay. Yes. Definitely that I will be try to be explain as per my understanding. Because first of all, I would like to clear that this work is done by some collaborations. But based on my understanding that I would like to happen whenever we are having this like interactions between the nitrogen and sulfur, you can say. In this case, as I mentioned that we are having gold nanoparticles stabilized by citrate ion. So now as you can see in this, you can say pyrazole, we are having that binding site of sulfur and nitrogens. So now, based on their HSAB, hard soft acid base principle, that this gold will be preferred to bind with sulfur rather than nitrogen. That's why that it is more affinity towards mercury as compared to the nitrogen or of the pyrazole, you can say. Sorry, gold nanoparticle. I'm sorry.
Hello.
Yes, Dr. Rajkamal.
Okay. Thank you, Dr. Ramesh.
Yes, please. Any other?
No, please. Okay, thank you, Dr. Ramesh.
Yeah.
Now I thank again Dr. Ramesh Kataria for sharing his view on this platform and for sparing his valuable time for us. So I am also thankful to the organizer of this international conference, particularly Dr. Suresh and Dr. Deepa, Dr. Gulab, and the particularly mainly Dr. Satish Bhardwaj, Principal, Shahid Udham Singh College, Matak Majri, for providing me the opportunity for sharing the technical session of this international conference. Thank you. Thanks a lot. Now over to you, Dr. Deepa.
Well, thank you, Dr. Rajkamal. Thanks for being with us. Thanks for sparing your time and for chairing the invited talk that was delivered by Dr. Ramesh Kataria. Professor Ramesh Kataria, thank you so much for your informative lecture. It will be an inspiration for many researchers. Obviously, new ideas will be seeded by your lecture, and researcher will come up with many new innovative solutions to those ideas, those problems coming up in their mind when they were listening to your lecture. Thank you so much for sparing your valuable time and obliging us with your expertise. Thank you so much. Now, moving ahead to our next invited lecture by Dr. Brij Mohan. I would like to welcome Dr. Brij Mohan amongst us. I hope he's available with us. Are you there? Dr. Brij Mohan, have joined. Is Dr. Brij Mohan amongst us?
Yes, I'm here. Thanks for
welcome, sir. Welcome to the conference. And Dr. Ashwini Vihan from Kurukshetra University, Kurukshetra. Are you there, sir? Can we have your acknowledgement, please? Yes. So, moving further to the next invited talk from Dr. Brij Mohan, I would like to invite Dr. Ashwini Vihan, who is an assistant professor in the Department of Chemistry, Kurukshetra University, Kurukshetra, with a vast experience of 19 experience of research and education. Dr. Ashwini is with us, and I won't take much time so that we don't run behind the schedule. I would like to request Dr. Ashwini with heartiest welcome to kindly chair over the next lecture, please. Dr. Ashwini Vihan, over to you, please.
Thank you, Dr. Deepa. Am I audible?
Yes, sir, perfectly.
Okay. Thank you very much. Good afternoon to all, and welcome to this session of international conference that is organized by Government College Matak Majri. And first of all, I welcome to keynote speaker of this session, Dr. Brij, and I feel proud as well as it's my pleasure to introduce Dr. Brij Mohan, which is one of our students that is from Kurukshetra University, Kurukshetra, and he's acting as now keynote speaker. So I feel proud and privileged also. Okay. About introduction of Dr. Brij Mohan, he did his MSc and PhD from Kurukshetra University, Kurukshetra, and his topic of research is design and synthesis of novel molecular receptor for metal ion recognition, and more than 30 papers that is in national and as well as international journal was credited to his academic contribution, as well as 4 to 6 book chapters also credit to in his academic number. So I welcome Dr. Brij Mohan.
Thanks.
And over to you for the session.
Namaste, Sastikal Adab, and good day. Thanks for your kind invitation and a wonderful introduction. I can see my teachers here, my seniors here, so it's my pleasure to present this talk and this meaningful. I hope this talk will be very meaningful for the future trends and the current trends in the science and in the economy. So today here I'm here to present new biosensors for detecting virus species and what is the effect of on economy of this research we will discuss here. So thanks again. Yes, everybody know what is this. As people say it's SARS 2019 because its origin was from Wuhan, from China in 2019. And after this, it spread all over the world, India, in everywhere it spread. And till yesterday, it kills more than 51 crore people, affected 50 crore people directly and affected all over the world indirectly. And millions of deaths have happened to this one. It looks like flower. Some people think it is flower, but in the science, it is well known that it is the COVID-19 coronavirus. We gave this name COVID-19 because its generation was in 2019. So it looks like it's the general structure of COVID-19, but what actually it looks like? What is its actual structure? This is the structure of COVID-19, which have different type of signal sequences, peptides, and helical structures inside. So this could be the one reason why there is no any proper vaccine or there is no any proper cure for COVID-19, because it is the bunch of virus. No, it is not only single virus, COVID-19, or you can say SARS 2019. It is the bunch of many virus species, and every virus species have different helical structure, different tails of antibodies, and different biological species inside it. So it is very crucial, it is very critical to understand this structure. It has different structure. A, so the primary structure, which have different strand and different peptides are linked here, and structure B, so the side and the top views that can rotate after 90 degree can so the side and the top views can be seen here. Or in general, I can say there are a lot of biological species in this virus, and it affects the sensing system. It also affects the vaccination development system. So till today, it is very hard to say that we have any evidence of solid medicine for COVID-19 because its structure is very complicated and it is very hard to completely stop COVID-2019. There is one reason, that is its structure. So based on this structure, there are some sensing devices have been developed. So how to detect this COVID-19? So scientists work for this and they design some sensors. And they design it. If it is possible to detect viral RNA, then it is possible to detect COVID-19. There are various types of techniques available based on polymer chain reaction, based on luminescence sensing, based on electrochemical sensing, but we will discuss here optical detection and electrochemical detections, because these techniques are available in most of labs in the worldwide, and it is very easy handling techniques, and these techniques are not cost effective. These techniques are cost effective and can be available at small scale, even in a small room lab. It doesn't need a high circumstances or high conditions. It doesn't need. So I will go back a little bit from here. It looks like a flower, and it means it's a bunch of many virus, and it is the structure. Structure A show the simple, and structure B show the bunch of top view and the side view of the COVID-19 structure. So here, scientists recognize that if we can detect viral RNA, we can find solution for the detection of COVID-19. So based on these data, scientists develop some optical detection, some polymer chain reaction techniques, and some electrochemical detection techniques. But here I would like to discuss some nanomaterial-based sensors. Why I speak nanomaterial-based sensors? Because nanomaterials could be based on metal ions, could be based on some carbon-related compounds, and they can be fabricated. Most of the nanoparticles, if you take in the non-fabricated form, it is very hard to develop as a sensor, because lack of the binding sites, lack of the stability, and lack of the signal existence. But nanoparticles, simple metal nanoparticles, or some carbon-based nanoparticles, or biomolecules based composited, they can be designed in many ways, like here, metal ion insertion. In the nanomaterials, we could insert some metal ions like cerium, and some highly sensitive metals, luminescence sensing metals, or it will affect the surface properties, and some another materials like inserting electroactive sites, some sites which are electroactive, some molecules, biomolecules like DNA molecules, they can be inserted. Some composite materials could be prepared by inserting biomolecules with the nanomaterials. It will be resulted in new materials known as the composite materials. In another technique, there is the surface sensitization and carbon material insertion, because carbon has various type of categories: carbon nanotubes, carbon rods, charcoal, activated charcoal. They could provide a surface for binding viral RNA. And control synthesis, it could be helpful to design some new sensors for virus-related species. And another basic point here I want to discuss here, inserting color-generating materials. For some ruthenium complexes, they generate color. So the combination of nanomaterials with some color-generating materials could provide new generation of materials, composite materials, and multifunctional sites. Because to generate a sensor, it is essential to provide some multifunctional sites, because multifunctional sites like nitrogen, sulfur, oxygen, and this type of molecules, this type of functionalities in the molecules or in the composite materials, they can bind with the viral RNA. So it will affect their properties, surface properties. And another is the nanostructure constructions. This could be some sensor could be constructed based on their properties. So all these could explain all could be responsible for the generation of the materials, and the signal changes could be observed in the optical way, and another way is the electrochemical way. So this is the design of the sensors, nanomaterials. How can we design nanomaterials as biosensors or for sensing messenger RNA or so microRNA or RNA viral RNA species? It could lead next generation of sensors. So how does it work? How does the detection will work? Here I saw nanomaterials. They have with active sites. When the viral species like RNA species, they will contact with the viral RNA. There could be observed changes in the emission intensities. This type of technique could be used by using luminescence techniques or some optical other techniques like absorption techniques, or you can see another there are some colorimetric changes. So this type of observation could be. I prefer to design this type of colorimetric sensors to design viral species because these are fast and easy to observe. Any technical person, even no need for high qualified staff for this to observe viral sensing. So this type of, if we could generate this type of materials which could observe colorimetric sensing for viral species, it is the better way for the mass population to provide a solution. And another way that electrochemical signal changes could be observed when virus species contact with the nanomaterials. So here are some from literature which have already been used to detect virus-like species at a commercial level also. And we can say portable electrochemical sensor. Here, as I saw one portable, that sample could be obtained from the blood or saliva, from mouse, from saliva or blood. And the viral antigens, when they contact with the biosensor due to any oxidation redox reaction, so it could result in the change of the signals, and signal changes can be observed in the mobiles or any electronic devices on screen, and it can show results. So this development of this type of devices, as I discussed in this slide, materials could be designed from here. Nanomaterials can be designed as a virus sensor. Some materials could be designed for viral species, sensing species, by using all these techniques. And after development of the technique, the sample could be collected from the blood samples or from the saliva, and this sample could be used for sensing, for the remote sensing, portable. It can vary from one place to one place, and it could be used in the remote sensing areas. That could be very helpful for the leading next generation of materials. And for electrochemical, for the mechanistic, if we talk about mechanistic insights, it could be observed by simple oxidation and reduction process by the electron transfer. So signal changes could be observed as a sensing, and if there are signal changes observed, we can say the sample have affected with the COVID-19. And another way is here, you can see optical sensing. As a viral sensor, the sample can be collected, and this sample can be interact with the generated materials. What materials? Nanomaterials. And nanomaterials, after generation, you can see here in the slide, they add sample, they prepare for first Cas12a, one type of this type of sensor, and they add this reagent with the virus species and put at a particular temperature to activate the sample. After that, the colorimetric or signal changes could be observed by simple observation of luminescence or optical sensing. So I'm giving one example here. This is the COVID test report. Yesterday, last night, I I did it for my COVID-19 testing. It's me, and they took my sample. They collected my sample last night, and now results I can see on my mobile phone. It's the green code, and 24 hours they give nucleic acid test reports by generating by remote system. So, but this time they use polymer chain reaction to detect COVID-19. So here if some researchers, they are working in nanomaterials, here I suggest them to generate new materials to work with new materials and to fabricate new nanomaterials for viral species. Why I speak this slide? Because it really affects the economy. It really affects the economy, and the economy is affected by COVID-19. How? I will show you in the next slide. In 2013, this is the graph of the business. Because when COVID-19 come, every business is slowed down. Every business, even stock market, oil market, school, academia, even every business is slow and more slow. So it really, COVID-19 really affect every business, and many people lost the job, and job crisis. World is facing with job crisis. There is no job nearby in anywhere. This is same. So after this, we can see what scientists do now in business. This is a global image of sensor market. People who are working in the sensory research area, this could provide millions of jobs in the future. This is the graph from the global economic, and it shows from 2016 to 2026. It will really affect the next level of business. Every business is slowed down at this time. But people who are making sensors, people who are working in sensors, people who have business with sensors, they are making a lot of money from this. Now I was checking nitrocellulose membrane that has been used for making testing kits, and that becomes the highest business in the world for scientists and for the companies also. So I here suggest for the people working, even they do not have high education degrees, but they can work in this sensory area by designing some nanomaterials and can set up their own companies and can sell this project or can make collaboration this type of work with internationally level. It really will provide a lot of money and a lot of business and a lot of jobs for the next generation. So science can create a lot of jobs here in up to 2026. So with this, from all this work, I published 10 articles in the last year, and others are ongoing on the way. So I summarize here. If I would like anyone, if want to ask any question, they're most welcome.
Okay, now the session is open for any queries. Is there any query from the participant side? Feel free to ask.
Hello.
Hi.
Thank you, Dr. Bridge, for such a wonderful and informative lecture. My question is whether all metal ions can be used in sensing technique, or some special kind of metal ions which we can use in this technique.
Yes, it's a very nice question, and I would like to answer here. According to my literature survey, first I would suggest to like silver, gold, platinum, this type of nanomaterials. They could be used for design nanomaterials and for sensors due to their properties. And besides this, I also study like ruthenium metal complexes. they could be used for color generating materials, and cerium Ce3 positive that could be used for luminescence sensing due to their high electronic transition properties. So I think you get.
Thank you, sir. Thank you.
Yeah.
Hello, Dr. Briggs.
Yeah.
It was a very wonderful lecture, and you have presented within the time limits. Thank you very much. Dr. Bridge, I just want to ask you one question. That is there any difference between nanomaterial-based sensor or other metal-based sensors?
Yeah, actually, there are huge differences, like their structural properties. Basically, their structural properties, because to design a sensor, the structural and the surface properties are really critical points. Because if the surface is active and reusable, so it could be wonderful for commercial applications, like even at industrial applications, and it can affect the sensing proper rapidness also. If surface, for example, even particular other metals or carbon-based, I would like to explain it a little bit more. Like carbon-based nanomaterials, carbon-based and metal-based. But because metal have different oxidation states, so it is easy to observe electronic transition or electron transfer process. So I would like to suggest here that metal-based nanomaterials composited with biomolecules, not only metals, composite materials. They are used for biosensing materials. They can be composite fabrication, that process of fabrications that would lead new generation of materials for biosensors, even for chemosensors.
Okay, thank you, Dr. Bridge. One person, Ninu Sani, has asked you, can layered perovskites be used as sensors?
Pardon, please?
Can layered perovskites be used as sensors?
Layer materials. Yes, layer materials could be used. I want to give one key point here. Any material, any molecule you design, any type of organic molecules, molecule even you design, any morph material, any nanomaterials, if you are making composite material, if you can convert that material into the composite material, that would be really wonderful to generate biosensors, because it would change rapid properties. Give 1 minute, please. Oh, okay, sorry for interrupting. So one material, any molecule, organic, layered, that have different properties. But when you composite that material, when you fabricate that material, it will lead a highly efficient material. And that material could be used for fast, rapid sensing of physical sensor in heterogeneous medium also. And that could be utilized for industrial applications, not only for publication also, academia, but it could be used for industrial publications. Last time I was talking one of my business partner, because they are working in the sensing, so they hired some scientists worldwide who are working with materials, and they composited these, they designed some materials with nitrocellulose membrane and some other layering materials. And they generate new materials by compositing different multidisciplinary, the combined multidisciplinary research area, and now they have rapid biosensors. So it is really fantastic to design biosensors because it is the future. Are you okay?
Yes, Dr. Bridge.
Yeah, Dr. Suresh,
Yes,
I have one question with Dr. Bridge.
Yes, sir. Welcome, sir.
First of all, that I would like to congratulate Dr. Breach. He is doing wonderful for academics society. And then my question is, Breach, tell me that what is the exact situation of Corona-19 in China right now?
Yeah, actually, I'm telling you here, if in my actually the data, I do not have exact data in front of my eyes, but I will tell you the situation. If there is two or three cases in the city, they currently they immediately they check. They immediately they check this one. Could you see this slide?
Yeah, sure.
Yeah, there are results because they design new biosensors using nanomaterials, nitrocellulose membrane. Their scientists are working to design biosensors.
How much time is
And
required
every
for the
day-
reactions?
Pardon, please?
How much time is required for the results?
How much
time required for the results of the corona test?
Yeah, it is based. It depends. It vary. For it, they give results for within 1 hour, 2 hours, 3 hours.
Okay.
They are not any longer than it. Yesterday I did it, and they give me results immediately after 2-3 hours. When I go to home after checking, I can check it on my mobile. And this is the one screenshot I saw you here.
Okay.
It could be checked on mobile phone.
Okay, what about the acceptability of the testing in China of the people?
Actually, this time it is very strict.
Okay.
Somebody stuck outside from China.
Yeah.
They could not come back here due to COVID-19 situation because government policies are highly strict. Even I have to go another city. I have to take this test 24 hours earlier. And if I move to another city, every day within 24 hours, I have to check it. But they are not charging any money for it.
Oh, yeah, good. Yeah, thank you, Dr.
And
Breach. Thank you very much.
everywhere you can see there are a lot of in China they make checking stations everywhere.
Okay.
If you go to scale anywhere, you could check. And I want to focus here for every scientist because I know there are some scientists who are listening here. This is a global market. If you have some wonderful projects, it can create a lot of jobs for our next generation and for current unemployed people.
Okay, Bridge, we will discuss all these things in some platform. I think that we have that time constraint here that we will discuss at some other platform.
Okay, you are welcome.
Dr. Bridge, you can provide your email ID so that any participant
this is my email ID.
who are
Here is
interested
my email ID. You can see
may
this
be
is my
contacted.
email ID.
Okay. Is there any
other question?
Any other query from participant?
Sir, I want to ask you a question.
Yeah,
You're welcome.
Hello.
Yes.
Sir, how control synthesis can be helpful for your biosensors?
Right. Pardon, please.
How controlled synthesis, you mentioned in some point like controlled synthesis can be helpful for designing biosensors.
How controlled synthesis of sensors can be made?
Yeah, control. Yeah. I got it. Actually, it depends on what type of materials you want to design. By controlling temperature, sometimes slow temperature, cooling down, so hydrothermal, solvothermal, and different type of layering and grinding, chemical. This type of could be used for this. I would like to show you here some. This control synthesis that could be really helpful for designing this slide. Could you see here, please?
Yeah, yes, sir. Yes, sir.
So there are many ways for the control synthesis: chemical, mechanical, biological, to design some nanomaterials with very active sites. This is the high velocity deformation. You can take screenshot of this if you want.
Yeah.
Okay, sir. Sure. Thank you.
Yeah, so this is the highly informative to design some new sensors. Yeah, thank you. Thanks for any other
I think there is no
query?
more queries from the participant side. Thank you, Dr. Bridge, for providing us such a valuable and informative lecture. And that is also indeed an important one, because importance of sensors is likely you can say that, and trigger or the starting mechanism, starting factor for any treatment. If you can sense, you can diagnose. If you can diagnose, you can easily be treat them. Okay, thank you, Dr. Bridge. On behalf of all the participants and organizing committee.
Thanks a lot for your invitation. Really, it's my pleasure to present this
Thanks a lot to Dr. Bridge.
You're welcome.
Nevertheless, that is Dr. Deepa, Dr. Gulab, Dr. Suresh, that is organizing committee, as well as principal, Dr. Suresh Kumar.
I thanks
from Government College. I thankful to you.
Thanks everybody.
For
Thanks
providing me an opportunity to act as an session chairperson. Thank you very much, Dr. Deepa.
Well, thank you, sir. Thank you,
Gulab,
Ashwini,
Dr.
sir.
Suresh. Thank you very
Dr.
much.
Ashwini, Dr. Bridge, I extend my heartiest thanks to you on behalf of all the organizers for sparing your valuable time and for sharing your pool of knowledge with us. And since we are running behind the schedule, I'll be rushing fast with the announcement that it is the technical session 1 is over with this talk, and we'll have a lunch break. But before that, let me mention that if there are any other questions, because there were some hands raised, Mr. Amarjit Bhaiya had raised a hand but couldn't ask the question. I have shared the email ID of Professor Bridge, Dr. Bridge, in the message box, so you can ask the remaining questions through the mail. And regarding the feedback form will be shared at the end of the technical session 2. And regarding the attendance, you are all requested, all the participants are requested to mark their attendance in the in-call messages once, please. And with this, with the promise to meet you after half an hour, after the lunch break at 2 p.m., I would wind up the technical session 1. Thank you everyone for joining. We'll be back in session 2 at 2 p.m. Till then, you can have a good day.